Hi students, good evening. We'll start in 2 or 3 minutes. Hi, good evening. So, am I audible?
Yes, sir.
Hope that
Yes, sir.
my screen also visible. Huh?
Yes,
Yes.
sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. This is the quick revision session, which detailed kind of concepts which have been discussed in week 7, 8, and 9. So, where that summary in the sense actually we don't want to miss it that any kind of important concepts. So similar way, so within these 2 hours, we have to cover that 7, 8, and 9. Of course, ninth week is continued with the 10th week with the linking of graphs, where 7 and 8 are going to be both of them linked. That's like, both of them are discussing about dictionaries and combination of lists. So how the dictionaries are useful. In that way, 7 and 8 is linked. From the 9, remaining 2 also linked. Of course, we spend much time on ninth also because a lot of procedures are there and pseudocodes are there in the ninth week. So that is what the complete overview what we are going to work today. So let me start from the week 7. Prior to the week 7, so generally we do that all kind of pseudocodes and procedures using nested loops, because if you want to find out a pair of students in similarity of date of births, in similarity of marks, in similarity of cities, city or town they belongs to. So at that time, what you supposed to do is You are trying to use it as a uh, outer loop is available, and inner loop is available. So outer loop compares that each element taking one, the first particular row is taken or first card is taken, and it compares that remaining 2 to 29 or 28 cards is compared. Similarly, second card is taken, it compares with 27 cards. So that is what it is happening. Similar way, what you're supposed to do is whatever card you have seen, so that you have to move it from table 1 to table 2, something like table 2 to table 3. So that stands for we want to maintain different piles. So one pile is unseen file, and one pile is going to be a seen file. One table is already we have verified, and another table is which is not verified. To avoid this particular complexity, like using that outer loop and inner loop, and using multiple tables, all the stuff you can avoid by using simple and easy dictionaries. So that's what why the necessary of dictionaries came in the 7.1 lecture. So hope you understand, no, when you compare with that 1 to 6 weeks or 6th and 5, when you think about nested loops and tables, that can be overcome by using dictionaries. Now let us we see the first example. So this could be the basic example. In the lecture also the prof has been suggested. So for example, so you have that uh, scores data set is there. Once you see a card, once you see a particular card of a student, we want to make that the card sequence number as a true. Of course, it is a key and it is value. So already they said it is, dictionary means it's a combination of key and value. 16 is the sequence number which is considered as a key, and we mark it as a value is a true. So remember, when you build the dictionaries, definitely a pair of two things is there. One is key and next one is value. And remember, here the pairs of the below equal marks. See, you can look at that. So the maths marks in the similar cards which has that card number 16 which has 87, and similar kind of mark you can find with the other student which is that 4. Same kind of 87 marks you can find with another student of 25. So that if you make it that whatever the status which you have seen it, the second card is compared with 16, third card is compared with 16, so something like that, the status we want to record somewhere, so that once you record this particular status is seen, we don't have a chance of that oversight. We are looking same card twice. That oversight things can be avoided by using the dictionaries. This is one example in the prof has been suggested how the dictionaries are useful. And once you go for that next example where the dictionaries are really useful, we want to create some kind of grades to the student. It could be like sequence number. The student number 12, where he got that grade of B. Student number 23, where he got that C. Student number 14, he got that A grade. And of course, remember, there might be a student number 16 who got that grade number B. So that once you think about this, here the B is repeated twice. You can look at that. This B is repeated for card number 12 and card number 16 also. So what exactly they want to tell you is the value can be duplicate. Value is duplicate. So you can have values are duplicate, but key is definitely unique. So we don't have key is always unique. We don't have a chance of that sequence number is repeated for two cards twice until and unless there might be a flaw in the data set. I hope you understand the second example. Okay. So for that, they want to tell you that one, the sequence number of the student, which grade he got it. So 23 student, which grade he got it, so that you can easily classify that. So the student number, which grade he got it, so where that grade is maybe repeated for different students. So what exactly this is useful is, later sometime I want to pick all A grade students. So what I supposed to do is, just simply I will traverse this dictionary and I'll pick all of this particular dictionary values and keys. Wherever A is found, that particular student sequence numbers I can pick out and I can put it somewhere. I hope you understand the second example. Is it clear?
Sir, can you explain once again?
Why? It's not a complex one. Okay,
You're so
Sir,
clear.
okay. I'll do it one more time. I'll do it one more time. Not issue. See, look at the second example. What they want to tell you is, each student sequence number, which could be the card number, can be assigned with a grade. So of course, grading point we mark it as, if a student crosses that 90 marks or 90 of each subject, or it might be that comparatively all three subjects total, there might be a point they'll put it, 396, 270. If any student got that 270 and above, all 3 marks combination, 3 subjects, then it can be considered as a grade. So when that 80 above each subject, it stands for that. So 240 and above, it's considered as a B, and of course C and D, some kind of grades they want to mark it, but they want to record somewhere, because the card is not having the facility. The card is having a predefined fields are there. We don't want to write anything on the card, but we want to record somewhere. That recording can be done with a dictionary. So the dictionary, it maintains the status of it. So what status it will maintain is, so for the student sequence number, a grade is calculated and assigned. So that here the key is nothing but a sequence number, and as per the calculation and computation, which grade he got it. Similar way, 23 got C, 14th student got that A grade, and there you might have a grade for a 16th student, he might got it same kind of grade of B. You might have, because both the 12th student and 16th student, both of them matching the criteria of the grade B, so they got it. Here what we want to do is, the values can be duplicate. See, look at here, B and B is repeated, but the key cannot be duplicate. See, the 12 is different, 16 is different. So the basic fundamental rule of the dictionary is, value can be duplicate. Values are duplicate, but the keys are unique. Keys are unique. So what is the advantage of this one is, after making a dictionary of 30 sequence numbers, with each student is assigned with the grades as per calculation, and I want to list it, finally I want to list it, students sequence numbers who got A grade. Simply what I'll do is, I will iterate through this dictionary, and I'll pick that each particular sequence number, wherever A grade is found, that A grade student sequence numbers, I want to store it in some list, and I want to print it. So that's what, if you maintain the status somewhere, you can easily filter the data. This is the second example they want to tell you. So storing the status of any verification, any calculation you've done it, and that you store it somewhere, and then later you can use it. So now I think you got it now. Is it clear?
yes, sir.
Yeah. Now example 3 they are going. Another example, because till now example 1, example 2, they talked about scores dataset. In the example 3, they want to talk about that words dataset. See, look at the words dataset. Words with same letter count. So if you want to do the same letter count, what I supposed to do is I have to take the first word with the outer loop and then compare with remaining 60 words. So first word letter count, is it matching with any of the 59 words in the next? Second word you pick up using outer loop, then inner loop is repeated again 58. Am I right or wrong? Generally we do in that way, no? Because
Yes, sir.
Yes, sir.
similar pair of words you want to find out in terms of letter count, the length of the word. But here the dictionaries, it is giving a facility. What I'll do is simply I'll do that iterating the each word and store length of the each word, like first word, second word, third word, fifth word, seventh word. So it need not be that in sequential order, remember, but the keys are definitely unique, because even words data set also you have sequence number is unique. So once you got it each word, that is word sequence number, and followed by it's a length of it, it's a 9 and this 5 and this 7, all these are length of the words. So later what you do, you store it all these particular using one iteration, you store it. Later simply what you do is you can pick out that which are all the words are having that equal length. Simply wherever the equal length is there, you can find out it. But thing is, how to create this dictionary, that's what they said it, whenever a letter count is found, set's initial value is 1. So what exactly, as and when a new card is got, a new card number, or we can say that sequence number. So whenever you got a sequence number initially, so for example, I'm right now I'm looking third card, immediately third card is traced, I will add to this one is initially 1. Then the third card is having 4 characters might be that THAT. Is it clear? Now the first character, as and when T is found, immediately 1 is given. After that HAT is found, 1 plus 1 plus 1 plus 1 is added. That's what it is called. Then increment it by one after another, finding that similar kind of, I'm sorry. This is somewhat different. Actually, letter count is okay. So whenever a new letter count is found, set its initial value is 1. Then later, so one after another, we find that similar letter count of it. So I'm sorry, this is a wrong way I have been calculated. I thought it is how this dictionary is made. The dictionary is already created. Now we have to trace out that which are all the words. So you are having that similar kind of letter count. How many words are there? We want to find out it. So I want to erase this part. Please ignore this part. So this dictionary is ready. Of course, what I said it, yeah, how this dictionary is made, I said you. But this is not related to this note. This note, what it wants to tell you is, once this dictionary is available, for example, 2361 is there, you have the 17th word is there, which is also having length of 15. Clear? You might have 18th word is there, which is having a length of 9. Clear then? Now
Yes, sir.
I want to count it, how many words are having equal length of characters, equal length of letter count. So in this case, if you think about that, there is 2 words are there which is having that equal length of 15. There are 2 words is there which is equal length of 9 and 9. So you got it that 2 words are there. So what I'll do is, whenever a new letter count is found, so set its initial value to 1, then increment by each one after another, finding the similar letter count. Here indirectly we compute something with existing data. This is called existing data, existing one. So using existing data, what I'll do is, first I'll get 9. So as and when 9 is found, the first one, what I supposed to create is, it is a first word, so that I'll make it 1. So then that another word I found that with a letter count of 50. So 15 is a new one. So that 15 is counted as first word. Then 6 is there. Sorry, 7 is there. So 7 is being founded as the first word. After that 17 is there. What is its letter count? 15, no? Is it right? Is it right then?
Yes, sir.
Yes, sir.
So already 15 is there. So it is been added with plus 1. Simple. So whatever values we have taken here, these values later you are creating another dictionary. This dictionary, what it will do is the values extracted from here created as keys now. Here, value is incremented. Simply value is plus one incremented. So what simply I'll get it is, so whatever that duplicate words with same letter count is there, not mean the duplicate words in terms of similar length of words. So there what happens, it will increment it. So 9 is already available. So it doesn't add it as a new dictionary because dictionary allows only one key at a time. So already 9 is there. Simply it will increment that plus 1. So after complete processing, you get it that how many words are there with a letter count of 9. How many words are there with a letter count of 15? How many words are there with a letter count of 7? So simply we get a new dictionary. So this is what advantage of maintaining dictionaries. If you record the status somewhere, you use the status to somewhere else in the next process, whatever you want to do. If that is not there, you supposed to use outer loop is required, inner loop is required. You need to move that one record count to another table, one pile to another pile. So it is something complex kind of procedures. To avoid it, we went for it. And another example they talked about it. It is one other interesting kind of example. See, same scores data set they have taken. Scores data set is having the total, it's 0 to 29 students are there. What I want to do is, how many students belongs to that city or town in Chennai? How many students belongs to Bangalore? How many students belongs to the Madurai? So we required only one while loop, that is until end of that cards. So inside, what I simply create is, if a new particular city and town is found, when a new particular city and town is found, we make that Chennai as 1. So when Bangalore is found, still now Bangalore is not there, so it will make it 1. For example, another student we got it. That student belongs to Chennai. What I'll do is existing value plus 1, so that I will increment this Chennai like this. As and when every student you found with Chennai, I'll increment the Bangalore. So that is what happening. So using one loop itself, one iteration itself, you can do this job. So simply, so you maintain the status of the earlier visit and you update that the latest visit update into the earlier dictionary value. So keep maintaining the dictionary is the advantage. This is what advantage of it. This is the 7.1 lecture, how really different examples, where really the dictionaries are useful. If you go for the 7.2, they talked about birthday paradox. See, look at, if you think about birthday paradox in the earlier, you supposed to use nested iterations. You required outer loop is required, inner loop is required. We try to pick out that students who are being born in the same month. Like, we want to pick out that 12 months categories who have been born in the Jan, who have been born in the February. So similar way, you're supposed to bring them outer loop and inner loop. So outer loop, it contains that 1 to 12 times of month names. Inner loop, it contains that each student, whether he belongs to that first month, whether he belongs to that second month or not, we check with inner loop. And one more way is sorted by date of birth. Also another approach we tried in the earlier lectures. I think so it is in the 6th. But you can avoid completely. You can avoid it. Simply we can avoid it. Outer loop you can avoid. Inner loop we can avoid it. Very simple. Even sorting also you can avoid it. Because, see, simple. What I want to do is use the dictionary, which is very easier. because dictionary allows always a key is always unique. It doesn't allow similar kind of key in the same dictionary. So 15th March, if first student is found, it will update that sequence number. So which student is that? And same date of birth, if you found another student, is sequence number also we want to update. But remember, when you update, here we did it increments, here we did it what? Increment, +1, +1, +1. Here what I want to do is I don't want to increment it. I want to maintain another sequence of list. So what it has to be supposed to be is list. So what exactly, dictionary with list inside. So what exactly, as and when a new particular date of birth is found, simply we append it, whatever sequence number is there, this sequence number, we want to append it into the dictionary list. So initially this dictionary list contains that empty. Keep on adding, when your new date of birth is found, immediately it is going to be added the sequence number. Similarly here also, only one student is there, even one student is there, it is considered as a one particular list. So this is called, dictionaries can be appended with list also. We call it is, nested kind of it. So only one outer loop is enough to maintain the date of births along with which students belongs to the same date of birth or who have been born in the same birth date. So this is another advantage of using this dictionaries in the data structures which you are trying to use in the computational thinking. So here, see, look at, there is a complete pseudocode has been given for different kind of real-time examples. So shall I proceed for this one?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. So now look at, this is the first example. What this first example is, we want to extract each row from the scores dataset, and we want to maintain that the student name as a key and marks as a value. Understood that? The student name, maybe Avinash, as a key, as a key, and his marks, which is the marks is which is going to be chemistry marks, maybe 70, 80 got it. This could be the first one. So once Aravind is over or Avinash is over, Kumar. So 98. So this way they want to maintain it. So what they do is, initially empty dictionary is available. This is empty. So later we try to read each particular row from the table, from the row or from the table. First card we read it in terms of X. And remember, additionally they use a local variables. Actually it's not necessary. Of course, for easy understanding, the field value of X dot name we are getting into local variable. The field name of X dot chemistry marks we get it into local variable. After that, they want to create the name as a key and the marks as a value. So once this is created, so whatever that dictionary has been made using that particular row they want to put it into that, that is another table. That means it is filtered and we are got it that status of that each particular student is. So now processing the dictionaries. See, already dictionary is ready. So what the dictionary is, this could be a dictionary called, chemistry marks dictionary, which is ready and pack is ready for you. A packet is ready for you. What the packet it is, student name followed by his chemistry marks. Student name followed by his chemistry mark. Similar kind of packet you can make for maths also. Similar kind of packet you can make it for physics also. Now, once packet is ready, we want to process it. See, I want to do that calculation of average marks for the chemistry. So simply what I'll do is, the package is ready. The package ready is that called, chemistry marks. In that we are extracting only keys. Only keys means what you get it, the name of the student you get it. So using the name of the student, we extract we extract marks associated to student name, because student name is a key. Student name, they used a key. So whenever this key has been sent as a parameter to the left and right square bracket, subscript operators, it will extract the value. That value add up into the total, and of course we want to count it with a local variable, because I have to do that. A denominator is required, so we are maintaining a denominator. So that denominator we have been using for division purpose. So that's what the local variable total is maintained, local variable count is maintained. So we got that chemistry average. Same procedure you can use it for maths, same procedure we can do it for physics. So this is what, a simple package is ready with all chemistry marks, a simple package ready for physics, a simple package is ready for maths. As and when we want the average, simply we can do that average calculation and just simply do it and return it. And after getting three different averages, you can compare which of three different subjects, which of the average is best, which of the average is poor. So once dictionary is created, iterating through dictionary is easy, and processing the dictionary is easy, because the actual huge data, it comes into your hand in a compact format. This is what advantage of dictionaries. A complex data, it has been come into a compact format. That compact format you can use it for further any computation or calculation. I hope you understand the processing of dictionary. Okay.
Yes.
Through key we
Yes,
are
sir.
through key we are accessing. Simple. Now, so another another example they have taken, which is the customer bills. So if you look at that customer shopping bills data set, each particular customer name is at top right corner. Of course, it's left or right corner. I'm not sure that, but definitely one side that shop name is there, one side that customer name is there. At top right corner, you can find the sequence number of the card also. Below that you can find that item and item category and quantity of that they purchased it, and along with cost of that, and then sorry, price of it, and then that cost. So the each particular unit price and the total, it is calculated each individual one. For example, a food item is purchased with 5 items, each of the item cost is 30 rupees. So it's going to be that price calculated is 5 into 30, it's 150. So something like that. And at the bottom of the card, you can get it, the total of that, all the bill, complete bill done by done by a particular customer. So here, what they want to do is relationship among the customers based on their spending pattern. So spending pattern means what, this Abhinav has been participated in different purchases at different stores also. I don't mind that which particular store is, which particular shop he purchased it. Nirja, Akshaya. But spending patterns is there. So what the spending patterns is, so this Abhinav, he purchased its apparels, food, and he might purchase it, toiletries, utilities, and households. So how many purchases he did for apparels from all of the bills is 34, food items is 8, and toiletries is 2, utilities of course it's 0 or empty, something like this, and household is 1. Similar kind of numbers is there for Neeraj also. What they want to do is, based on the total purchase of the each customer, we want to find out the similar customers who are buying more than, sorry, of course it's not then, it's a than, more than some X element or any other food category. So what I want to do is, let you think that Nirja has purchased it 31 apparels. Akshaya purchased it 20 items of apparels. And in terms of the food, Nirja, let me take that items, food items she purchased is only 3, and Akshaya she purchased it only 2. So what I want to do is I want to find out similar customers in food. Similar customers in the food in the sense the distance of difference, the difference between A and B customer not greater than 5. So what exactly, when you subtract between that first particular customer A and B, the difference should not be that greater than 5, means that means less than 5, like 1, 2, 3, 4. In this case, if you compare Abhinav and Nirja difference, you see that it's a difference is 5. Maybe you consider. So these people are similar kind of customer. When you compare that Abhinav and Nirja, so if you look at that Abhinav and Nirja, the difference is that 6. We don't want to consider they are the similar kind of customers. So when you compare Neeraja and Akshaya, they are again similar kind of customers. See, look at this Neeraja, oh, this Neeraja and Akshaya both have been similar kind because the difference is only 1. So what I do is, based on the similar kind of customers, you can give some kind of offers on the food item. Like, some discount has been offered. So where that food item, so that these people have been the repeated customers. Same kind of rules you can apply for apparels also. The difference, you can take a minimum distance between these two. Based on it, or these two customers are same kind of customers. So whatever the discount you offered for Abhinay, same discount you can give it to Neeraja. Whatever discount given to Abhinay, you need not offer same discount to Akshaya, because there is a lot of variation is there between Abhinay and Abhinav and Akshaya. So this way you can do that one. I hope you understand the relationship identification. Is it clear?
Yes, sir.
Fine. So now, yeah, spending patterns, another part is there. Just wait. I'll mute that everybody. There is a disturbance there. Yeah. So now, same particular whatever patterns is there, second part in the lecture, it has been continued. So I'm going to,
Sir,
yeah, tell me.
sir, after difference you are telling, can you explain once again?
No, no. Difference means, the difference should not be so far and so near. Like we want to put it some kind of margin. Like first student, when you compare with second student, who is better you want to compare. So I want to compare with the minimum marks difference of that 20 or 10 marks, which you can see that in the student scores. Similar way, what the particular customer purchases, they did it, like food items, toiletries, all these are no. How can you say Abhinav and Akshaya is same? There should be some comparison, no? Already data is there. Using it, you're supposed to create some kind of base rule as per your company rules. Is it right or wrong? Hello?
Yes, sir.
So that particular base rule, I want to make it from my particular shop is, I let it be my shop is Big Bazaar. I want to make a fundamental rule. If the difference between, like, quantity of purchased of food items between any two customers, if the difference is not above 5, like, below 5, the difference is allowed. Like, between 8 and 3, what is the difference? 5, no? Is it
Yes,
5 or
sir.
not? So that we can consider this Abhinav and Neeraja are same in terms of purchases of food. And similar way, you can't compare Abhinav and Akshaya because the difference is 6. But we already made a base rule. It is 5 below only. It should not be 5 above. Okay. We cannot make what discount is offered for Abhinav, same discount we cannot offer for Akshaya on food items. Is it right?
Yes, sir.
So that is what the margin we create. See, look at, so we can find similar customers who are buying more than some X items, some particular difference, 3 items, 4 items difference, 5 items difference. Like you put one margin of any category, example in food or any other category. So based on that, oh, these particular customers are same. Whatever offers you have given for Abhinav, same offers you can give it to some other similar customer. Okay, is it clear?
Yes,
Yes,
sir.
sir.
So same thing analysis has been done even your e-commerce websites or apps you are following. So once you have been spending a particular thing, in the social media based on your particular reviews and comments, who have been same kind of reviews and comments in the Vizag region, because you have your geographical data also from which place you are ordering. So whatever reviews and comments you are giving, and whatever the who is a neighbor who is giving the reviews and comments, based on it they try to recommend the products. Like your neighbor is recommended and given positive reviews for product, same product they try to give a alert for you then. So you try to purchase this one because recently it is been having the positive reviews. Maybe that is what similar kind of customers they want to find out it based on the reviews. That is one more kind of example. Actually it is not that much complex one, but it is very simple because it's a computational thinking. Now same patterns they want to use it in the another lecture of 7.5. See, look at, compare each pair of customers. Each pair of customers means Abhinav and Neerja is compared, Abhinav and Akshay is compared. Similar when Neerja Akshay is compared. So you might have another third or fourth and fifth in particular number of customers is there. Compare each particular pair of customers, compute their distance. See, already I said no, these distances of each category of purchases. Here you take absolute value. Absolute value means the difference is absolute value. For example, the difference between 31 34 is 3. The difference between 31 and 21 is 11. Clear? So here the difference between 8 and 3 is 5. The difference between 3 and 2 is going to be 1. Fortunately, top values you are having that higher values, lower values are smaller. For example, you might have toiletries purchased by Abhinav is the 2. The toiletries purchased by the Neerja is 17. So 2 minus 17, you get minus 15. Is it right or wrong? Is it right?
Yes,
Yes.
sir.
So this minus
Yes.
15 you want to convert into absolute value. That is called, converting the absolute value. Now they can do that between first and second customer. The difference is 7. The second and third customer difference is 17. The first and third customer is 2. So you can maintain compare with first customer with all customers in the store, second customer with all customers in the store, third customer is compared with 4 5 6 and keep on. Similarly, fourth customer is compared with remaining 5. I hope when you come to the last it is going to be decreased, because so always so nth particular customer is compared with up to n minus 1 only. So you can compare it and you can store it, the difference, how much the difference is. Of course you store it that absolute value. So this absolute value you can have some particular distance, minimum distance allowed is, or maximum distance allowed is 10. If the difference is 10, these particular customers are same. If the difference is above 10, they are different. For example, 1 and 2, in terms of purchases, the difference is 7. So these are similar kind of it. But when you compare with 1 and 3, the difference is 20. So they are not same. 2 and 3, not same. So 2 and 4, not same, because we put it that maximum distance allowed is 10. Of course, minimum distance you can say one distance also allowed. I hope you got it. Fine.
Sir,
Hmm.
sir, what is an absolute value?
So when you subtract, so less positive value from a negative value which is higher, like 7 minus 13. So here that minus 13 is a bigger one. So what it will dominate. So what is the result? What is the result?
Or can we say that it's non-negative value,
Yes, exactly.
absolute value?
Minus 6.
Minus 6, you get
Minus
it,
6.
no? So minus 6, it is converted into absolute of minus 6. it will result 6. Clear?
Yes, sir.
So that it doesn't allow that negative values. So signed value converted into unsigned value. That means every negative value converted into positive. Clear?
So,
Hmm.
Yes, sir.
so in the above example, you have taken the difference and of A and B should not be greater than 5.
Hmm.
But in the above example, it's given like we can find the similar customers who are buying more than some X items in
Hmm.
the food. How
Hmm.
these two are linked, sir? Can you explain it?
What is that? Tell me once again.
So the that customer name as key and category example, Abhinav
Hmm.
Nirja one,
Hmm. Hmm.
we have taken that so difference of A and B should not be greater than 5,
Hmm.
like 8 and 3, that one.
Hmm.
But in the second line, it is written that we can find the similar customers who are buying more than some X
Hmm.
items.
Hmm. X items in the means the difference. This difference 34 and 31. Difference is 3. So these 3 items, in terms of that apparels. X items means what? The apparels items. F is nothing but food. So in food. So in food, 3 items. Understood then? The difference is no X items. 3 items, 11 items, 5 items, 1 item. Okay. In any category, either food or any category. Clear?
Okay, sir. So their
Okay.
difference should not be greater than 5.
Yes, something we
And
put it as a benchmark. So within that benchmark only we call. So here, so that is explained. So whatever I explained here, so similar thing they expanded it. First and second customer, first and third customer, because Abhinav is compared with remaining all customers. Neerja is compared with remaining all bottom customers. Is it right, Ryan?
yes,
Yes, sir.
sir.
So that when you compare it, so one is compared with two, difference is 7 in the sense it might be difference of any item or it might be the sum of these particular things also. For example, this total, if you consider 34, 42, 44, 45, maybe it is 45 items he purchased it. Is it clear? Maybe near the total you compare, it's a total, if you do it 30, then what I'll do is the difference between total purchase of all items in the bill, you can make it maximum difference allowed is 20 because you did total, no? Is it right? Hello?
Yes, sir.
So
Yes, sir.
in that case also you can do it. You can do a cumulative total of all purchases of Abhinav, all purchases of Neeraja, all purchases of Akshay. So then you can find out the distance. Understood?
Yes, sir.
So that's what the thing with the next still they are spending patterns, the relationship between two customers, how to do it. So they have been just explained in the second 7.5 lecture. Clear?
Yes,
Yes,
sir.
sir. Sir, absolute means.
Hmm. So what's absolute? No, I said already. Absolute, it never returns negative number. So because we are checking if condition, the difference is less than or equal to 6 and greater than or equal to 1. Is it right? Is it right then?
Yes, sir.
So in this means what, it allows only positive numbers 1 to 6. Fine. Is it right then? Okay.
Yes, sir.
Now when you calculate difference, A minus B, A is customer A, B is customer B. Clear? So the total quantity of A minus B you are doing, if A is bigger, you get positive number. For example, A is smaller. A did smaller purchases than B. What number you get it difference? Negative or positive?
Negative number, sir.
Negative.
So when you get negative number, this condition is satisfied or not?
Yes, sir.
No,
Is it satisfied or not?
No, sir.
not sir.
Not satisfied. So then what you do is we try to enclose this in absolute function so that the whatever negative difference you got it, that will be converted into positive unsigned value. Clear?
Yes, sir.
Simple.
Yes,
So
sir.
it takes a negative number and it simply converts into unsigned value. Now,
Sir,
yeah,
sir, can I ask from where you get this summary PDF?
No, no, summary PDF. I made it. I walked through the lectures and then I did it. That's it only.
Oh, okay, okay. Can you
Okay.
share it?
Sure, sure. I'll share it. I'll share it because I'll request him that tomorrow they'll put it in the dashboard or it might be. Uh, so where it is
Yeah, that
feasible,
will
I
be
think in,
useful, sir. Thank you so
yeah,
much.
this course or it might be in the dashboard. Otherwise, in the discussion form is there, no? Google form. Form is
Uh,
there. In the form is there,
yes.
no? I'll ask
Sir,
them to put it.
please put it in the portal, sir, dashboard, sir.
Okay, okay. I'll ask them to put it in the dashboard only. That's better. Okay.
Thank you, sir.
Three
Yeah.
summaries,
Yes, sir.
definitely. Yeah. So now it is the dictionaries. Actually, practically, they did the dictionaries. Then they want to understand that what really the dictionary is. So the dictionary is simple. Introduction to the dictionary. So actually, they use a dictionary, but they did not tell you that what really the dictionary stands for. So dictionary is, yeah, build a dictionary which is a stored name as a key and count the food items as a value. See, only the food items they want to count it. So store name SV stores. So they want to count it that only food item summary. So whatever the food items have been purchased by different bills, bill number one is there, bill number two is there, and three and four and five and six. So in this each bill, you have lot of items, a big list is there. This one also having a big list. What I want to do is all these bills have been belongs to different stores. I want to count it in the each bill how many food items is there in SV stores, how many food items till now they sold from Sun General and Big Bazaar. First they pick out the bill number one and they count that food items. They try to add it like plus first bill food items plus second bill food items, third bill food items of SV stores. This is exclusively SV stores food bills have been extracted. And similar way, Sun General, all bills have been traversed. So from the all bills, they try to add it. So food items of Sun General. So how many bills is there for Sun General? Same thing is done for this Big Bazaar also. This is what they did it. Based on the above dictionary, we can come to a conclusion that SV stores is famous for food. I hope you understand because you have that 60 or 70 bills is there or 30 bills is there or 20 bills is there. We have been investigated all the data. So all the data we investigate on the food. So where the SV stores bills have been got that highest count in the food, because of that food is famous in the SV stores. I hope you understand. Clear?
Yes, sir.
Similar way, they build another dictionary of customer name as a key, count that food items as a value. See, look at here. So I hope already I said, in the left corner, you can find the store name. In the right corner, you can find that customer name. So that every bill is associated to the customer name and at the same time store name. So I want to count it. So this customer Rajesh, till now he did it two or three bills. How many food items he purchased? Abhinav, how many food items? So Akshaya, how many food items? So based on it, you can come to a conclusion. Maybe Akshaya as having a big family, which is could be a combined family. So that could be the reason they are purchasing more food items. I hope you understand. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So that the dictionaries are much useful to maintain the status of the data and put it somewhere. Later you investigate and you do analysis, data analysis on the dictionary, and you can come to some conclusion. Oh, this pattern of data is giving you this behavior. Oh, this customer is having this kind of behavior, this store is having this kind of behavior. So most of the times the data analysis what you did definitely gives you that correct behavior in the future what the customer may do it. So now they have given pseudocode examples. See, look at. So in the lecture, one particular lecture is giving exclusively the slides with pseudocode. See, look at how to create these dictionaries. Whatever dictionaries you have seen earlier, that dictionary is how they have been created. Basically, they want to create a dictionary with empty, initially empty. We want to traverse all the bills, all the rows, extract each bill. X means here each bill. In that customer name, items is extracted as local variables. What you did it for the earlier kind of maths marks or chemistry marks for average calculation, you did it same thing. Now, so if the category is food, whenever you find a food category, we try to create that is key whatever the food quantity. So whatever the food quantity they have been, this particular is called dictionary, which is empty dictionary initially. Later, it's an empty dictionary. If the particular customer is not existed, because they side it is not sorry existed, I'm sorry. I'm sorry, I thought it is not existed. Yes, it is existed. Yeah, empty dictionary initially. If it is existed, we do something. If it is not existed, we do something. This is not existed. I thought it is not is keys there. So whenever empty dictionary you take it, the first customer you pick out, definitely it is empty dictionary. Empty dictionary checking the customer name existed means definitely it's a false. Then simply the particular customer with initial count is 1. Again, another bill has been traversed. So another bill has been traversed, sorry. So another row is traversed. For example, in a single bill, you are having 15 or 20 items is there. So in this, maybe food items you found it here, here, and here. Other items are some other items, category of that particular item is. So as and when in the customer bill you found a food item, simply we are doing +1, +1, +1. That is what for the existing customer. So that what happens, for one particular customer, this is the customer, this particular customer bill is investigated, all food items have been added. Similar thing is happened for another bill also. So what happens, so the Ravi is a customer, his total count of food items is being maintained. Kumar, his total count of food items is maintained, 36, something like this. For example, so a particular Rama is there, he has just purchased only one item, so that this is 1. I hope you got it. So this is what customer with cumulative count of all the food item, count only, not adding quantities, only they are counting. So how many kind of food items, category food items they purchase, they are not adding quantities. So this is one particular pseudocode. If you look at another
Sir?
pseudocode, yeah, tell me.
Sir, what does this is key represent?
Yeah, is key is whether the key is available in the dictionary or not. See, as and when dictionary is available, first time it is empty. Is it right?
Yes, sir.
So that dictionary name is food D. That so first particular customer is red. First particular customer name is some Kumar. Is the first bill. Kumar bill has been investigated. So now, does this customer Kumar is existed in this dictionary or not? Tell me true or false. Is key, what it will do is it search for a dictionary with a key, whether this key is present in the dictionary or not.
No.
If it is not found, so it returns that false. If it is found, it returns true. So if this is key returns true, means already this is not empty dictionary, the particular customer is existed. So when it is existed, we do +1. When it is not existed, just we initialize with 1. Clear?
Yes, sir.
That is what. Is key is for investigating whether the particular customer or particular key is available in the dictionary. If it is found, it returns true. If it is not found, it returns false. So if always checks for true or false. If true, it do something. If false, it doesn't do something. Okay.
Yes, sir. And so, what are these square brackets used for? Is it for list in this case?
Here, no, it's a dictionary only. So always dictionary name with square bracket indicates that which key you are updating. The key.
Okay, sir. Okay, sir.
So key has been setting with a value. Clear? Yeah.
Yes, sir.
Now,
Sir,
birthday paradox.
these
Hello?
all will store in that food dictionary, na? Food D.
Yeah, it's all food stored in the food D only because initially it's empty. This is all completely food D. This is all completely food D. Okay. It is expanded completely then. Okay.
Yes, sir.
So now, birthday paradox. See, look at the birthday paradox. What they are doing is they are taking two dictionaries. Birthdays they are taking, duplicates they are taking. So initially, we are trying to read that each particular card from this course dataset. And of course, X is nothing but each card. Local variable is taken, that is date of birth. And one more thing is taken, it is sequence number also. We want to maintain that the sequence number, which is similar kind of date of birth, is available. So as and when you find it that a particular date of birth which is key of birthday. See, birthdays is empty dictionary. For example, you found that Kumar, his date of birth is 7th March. 7th March. So this is a card you find it there. So then what it will do, locally we are storing date of birth and as well as sequence number also. Of course, sorry, it is a sequence number. I don't want to mention like, the sequence number so that it makes sense. So what it will do is, the duplicates is there. The duplicates, what it will do is, there is a dictionary is created, duplicates. It contains initially empty. As and when you find the first date of birth in the first card, definitely it is not existed in the duplicates. What it will do is, it doesn't execute this part. It goes to else part. It goes to else part. In this else part, what it will do is, whatever date of birth you found it, like 7th March you found it. This 7th March, initially another nested dictionary is created. This is called another nested dictionary. See, duplicates is a dictionary. Inside another dictionary is created. Is it right? Is it right then? Hello?
Yes, sir.
So then immediately another dictionary is created. What is another dictionary? Birthdays. This is also empty initially when you are investigating the first card. So at that time it is empty. Then what happens? The birthday is created, that is 7th March. And what happens? Inside of this, another dictionary is created. Which particular student date of birth it belongs to? Which particular student is maybe the sequence number of 7? Is it right? Maybe the sequence number of 7. Immediately what it will do is true. Is it right then? Hello?
Yes, sir.
Yeah, it
Yes.
will make it is a true. So we found that 7th record, and which is having 7th date of birth is a March. Sorry, it's not 7. You make it 17. The student 17 is having 7th date of birth. So we have searched that particular. You have already read the card. We make it as a true. That's it. We make it. So this is the first record is over. First record is over. Now second record you are reading. Second record, what you are doing is another record. Maybe fortunately you got that another record. It is also 7th March. Of course, the sequence number of the student is 4. 4. Then it comes to here. So now birthday is already available or not? Is it available? Is it
Yes,
available or
sir.
Yes,
not?
Yes,
sir.
sir.
Then
Yes.
immediately what it will do is, it will make that inside value is true. Inside value is true. And one more thing it will do. What it will do is, again, that date of birth of this new sequence number is added. What happens, same 7th March, another item is added for the same sequence number. Another sequence number is added, same 7th one. It is added with another sequence number, which is, 4th student. It is also investigated as true. Is it right then? Did you get it?
Yes, sir.
Yes, sir.
Yes, sir.
So that 7th March is investigating all of the students who are having that same kind of date of birth. And here what it will do is, some date of birth is there, 13th March, it left over as empty dictionary only. If it is empty dictionary, what does it mean? 13th March is available for only one student. We don't have duplicates. I hope you got it.
Yes, sir.
Wherever the date of birth with true is there, you definitely you find that students with multiple sequence number belongs to same date of birth. Clear? So that is done. Now another example. Example number 3. Yeah.
Sir, when we are running the second pseudocode,
Hmm.
why, when we first check it out, so why first if case is not working and first we are jumping to the else case?
Hmm. Hmm.
No,
Because
that is my
empty,
question.
no,
Huh.
because as and when a new student is there, first student, does
Mhm.
7th March, is it available in the list or not? Tell me.
No, sir.
When it is not available, this condition is true or false? Tell me.
It's false.
Then it goes to here. Simple. First student, definitely it goes to here. Okay.
Sir, but sir, if you're first checking, then the boolean should be false now. Why is it true?
That's what false, no? Is key false means it goes to here. First
Okay.
student. False only, it goes. True means that already one student is there with 7th March. It tries to add it, so that it adding process is done, it will make it true.
Okay, sir.
Okay then. Else part means false. If condition means true. They said it is key. Okay. Now another example they said, nearest noun proceeding to pronoun. So here, see, please, interesting part is, dictionary is created, part of speech. This dictionary contains two keys are there. See, one interesting thing is, initially the dictionary is empty. Later they created two keys. See, look at, these are two independent lines. Whatever these two things are, independent lines. They are not inside a iteration. Initially empty. After the second and third step is executed, what happens? First key is created a noun with empty list. Remember, it's a list. Clear? Similar way, pronoun empty list is created. This is empty list. Is it right then?
Yes, sir.
Yes, sir.
So
Yes.
that
Yes, sir.
two category of things you want to find out. It nouns you want to find out, pronouns you want to find out. Which are all the cards of nouns, which are all the cards of pronouns. That's what the target. Now the first card is extracted. That is card X. Now, if the card part of speech is noun, we want to update the sequence number into noun. So what happens? Here the dictionary keys are 2, but inside list is expanded. So what happens? The noun list is expanded, like 17th card, 19th card, 27 card. All these are nouns. This list is expanded because they are trying to append the sequence number. Fine. This is append operation. Fine then. New
Yes,
keys are
sir.
not added. So similar way, the pronoun also, it is expanded. Something like this one. So let it be that they want to find out that nearby pronouns and nouns, no? So we are taking it as here 21. Of course, I want to use a different color for the pronouns. Yeah, this could be better. So pronouns also traced. So I got the pronouns list also. with a dictionary called pronoun. Of course, same dictionary, but the keys is different. In this, I found that 21, 23, and 32, something like this. Now, I got that separate lists in a single dictionary, which is called part of speech. Sorry, yeah, this is called part of speech, where the list is expanded. So we got it. Up to here, it got it. So one part of things is over. Is it clear? Is it clear?
Yes, sir.
Now, whatever dictionaries you got it, this dictionary is already available, no? This dictionary is already available. Like a list of nouns is there, a list of pronouns is there. Now I want to find out, what I want to find out is each particular, yeah, each particular pronoun we want to find out in the pronunciation. So what happens, the sequence numbers, we get it. The sequence number, what you get it is these things. 17, 19, 27, you get it into P. So of course, first pronoun, so they are getting, oh, sorry, I'm sorry. Yeah, first pronouns they are getting into P, and nouns they are getting into N. So nested loop they are using. So initially matched is -1. The matched in the sense, initial setup value is -1 because negative value they want to make it. So here they want to get it that pronoun sequence number into P, noun sequence number into N. So using outer loop and inner loop. Of course, outer loop is P, inner loop is N. So now they want to do us, if noun is less than P, less than P means the noun is occurred before pronoun. Yes. See, look at 17 is occurred before 21. Is it right?
Yes,
Is
sir.
it right then?
Yes, sir.
Similar way, 19 is occurred before 21.
Yes,
So
sir.
this 19 is occurred before 23 also. Fine.
Yes, sir.
So what happens, this 19 noun is referred by maybe 21 or 23 definitely. Is it right then? Is it right?
Yes, sir.
Yes.
Similar way, this 17 may be noun. This is definitely referred by 21 or 23. So what I'll do is, the difference is when you got it, lower value of noun, higher value of pronoun is found, immediately matched the particular noun number is been taken. So whatever the noun is matched. So after that, we want to maintain a list, a separate dictionary. They want to make it a separate dictionary. Whatever pronouns is there, yeah, and they are matching with nouns that has been specified by it. So they are creating a dictionary called matched D. Matched D. So what it contains is the pronoun number as a key, and whatever matched noun is updated. So the pronoun noun number, if you take it, this pronoun number 21, it is matching to 17. So definitely it is updated, so that this pronouns 21, this, sorry, I'm unable to stop this one. Yeah. Okay. Yeah. This pronoun 21 is occurred after this 19. It is updated. So it is value is updated. Now, for example, say maybe this particular 21, oh sorry, I'm sorry, 17 I have to update it. I'm sorry. Yeah. This 17 has to be updated. Yeah. So now what happens, this 19 is taken. When you compare 19 and 21 also, same thing is happened. So what I supposed to do is, so this 21, it might refer maybe 19 also, but here 17 will go off, only 19 is there. Because of the recent update, what is there, that is only available. You don't have a chance of duplicate values. Is it right then? Is it right?
Yes.
So
Yes,
because
sir.
dictionary allows only one updated value, which is a recented value. So instead of it, if you maintain another list here, where you maintain 17 and 19 also, if you do append, instead of just it is, just it is making like this, You can make it appending job using plus plus. You can make it whatever matched one you create matched one and append it with a matched dictionary with a list, something like that. Dictionary inside a list you maintain, then all sequence numbers also you can maintain it. This is, yeah. So note that the part of speech noun and the part of speech pronoun both are sorted in ascending order. Oh, it is sorted in ascending order. That's the reason. Fortunately, I've given it's in a ascending order only, because all the words are traversed, 0th card to that last card. So that assumed it they have been traversed in the case of sequence number. So definitely these are being sorted, like 17, 19, 27, 21, 23, 32. All these are sorted so that comparison is easy instead of a random kind of orders. So this is pretty much about that 7th week. Is it clear?
Yes,
Just
sir.
give me 1 minute. I'll drink the water and come back. Yeah. So let's we go for that 8th one. So
So
yeah.
the in last code, if we in the match deal at last, we are taking first 17, then 19. That is possible.
No, no, no. Generally, it's not possible because latest updated value only it's there. We don't have that 17 and 19. So if and only you maintain like a dictionary with a list. That's what I said just now. Right now, this pseudo code is updating the latest value of the sequence number of noun only. So latest value of the sequence number is 19 is updated, 17 will go off. Clear?
Yes, sir.
That's the reason if you extend it a list inside a dictionary of 21, it's created like another list inside, then it is possible. 17 you can maintain, 19 you can maintain. I think I already said just now appending also. Clear? But this pseudocode
Okay.
is only updating the recent noun only. Clear?
Yes, sir.
Yeah. Now this is what they are talking about, that I think it is 8.1 dictionaries with a list. See, look at. So one particular example one. So it could be the follow-up session on the 7.1. Even in the lecture video also they have given. It's a follow-up session. Whatever they discuss in the 7.1, that could be follow-up one. See, look at what I do is in the earlier 7.1 lecture, the Chennai student, when you found him, another student, initially it is one. Another student, if you found that from Chennai, city or town, immediately you are trying to add it. Just simply, we are trying to increment it. But here it's, we don't want to increment it. We want to append it, the student sequence number. Which student is belongs to that Chennai? Which students belongs to that Bangalore? I understood that 3 students are there from the Bangalore, maybe 5 students are there from Chennai, but who are all they? So I want to maintain the status of the sequence number also, so that future reference is possible. So this kind of things is called, dictionary, a list inside. And another example they said, see, look at here, even shop with customer list. So Sun General, you might find it that 2-3 bills is there. SV stores, you might have 5 bills is there. I want to get it, the bill associated with which customers, so that I maintain the store name as a key and what particular customer that bill belongs to. So I understood that SV store 5 or 6 bills is there. That 5 or 6 different customers who have been involved in the particular bills. So I want to get it. So using the above list, you can compute some commonality between stores and customers. So what is the commonality? For example, Sun General, I found that Abhinav in the Sun General, same Abhinav I found in that SV stores also. You can take a look this one. So in this case, what I'll do is, as a data analysis, if you want to do it, so Abhinav, he went for the Sun General and he also went for SV stores. Does he purchase different items? Like, Sun General, he purchased exclusively food. SV stores, he purchased only that households. So at that time, we'll understand, oh, this particular Abhinav, he likes the food products in the Sun General. He likes that, or, so home particular products, appliances, or it could be the apparels or toiletries. So which he likes it from the SV stores. Otherwise, randomly you found it, Abhinav, he purchased same items, whatever in Sun General. Same kind of items he purchased in the SV stores also. Then we come to a conclusion. Maybe he does not have the feasibility to go to the Sun General. That's the reason nearby store of the SV stores he went and he purchased it. Randomly purchased it. So these kind of things, it is really useful, using above list, you can find out some commonality between stores and customers. And similar way, this is customers I want to tell you then. For example, in the stores, if you want to compare. So what I'll do is, SV stores is having that out of all the bills, 17 customers are visited for that SV stores. 36 customers are there for Sun General. And then you can come to a conclusion. Oh, Sun General is doing good business then comparatively the SV stores. And still you can do better. What you can do is, the Sun General, is it having the repeated kind of customers or not? For example, Abhinav, he did 17 bills. Same Abhinav, he did only 2 bills in the SV stores. So that Sun General repeated customer is Abhinav. Maybe randomly by some time he is not having sufficient time to go for Sun General. That's the reason he has chosen some SV stores. So you can find out, commonality between stores and customers. This is what advantage of maintaining a dictionary with a list. So simple dictionary with a list. So these patterns you can compare and you can do better computations. Still there is, just now I discussed about, if you maintain like a separate list, then you can track all of it. See, same thing. Pronoun, which is updated with the list, you understand, so whatever all the particular list of the pronouns, what are all the list of nouns, create order list of pronouns and nouns is there. Using the above dictionaries, you can find the nearest to, 9. That is his. Actually, their word existed. 9 is his. The prior noun is 2. 2 is contained Swaminathan as per the data set given. So his is referring that Swaminathan. Similarly, which is occurred before pronoun. And a pronoun 11 is there. Pronoun 11, he. It is also referring, 11 is there. It is also referring that the noun is, Swaminathan. So that because the prior one is 11 before, you find it 10 and 4 also. But it is definitely referring 4 because it is also Swaminathan. So that is, his and he, both of them reflecting the Swaminathan. Oh, it is definitely whatever pre-occurred nouns and current occurred pronouns is definitely refers that pre-occurred, earlier occurred nouns. This is what advantage of dictionary with a list. Now, dictionary comparison to find common elements in them. See, look at, here it's a common elements. This is a very interesting data set. Of course, it is late introduced in the CT weeks. In the earlier weeks, it was not introduced. But when you come to this one, train data set, it is really, actually earlier data set, all of the cards are similar cards. If you come to train data set, you can find that a train card is available. Of course, it is route, a train number, and there is another card is available, which is station. I hope you observe it. Did you observe this one? Yes.
Yes, sir.
So this train, what it contains is list of stations. It is attaching, list of stations. What are the stations it is going? And train is having list of, sorry, station is having list of trains. It is having trains. So here it is stations. Yeah, it is stations actually. So it's not visible. I want to make it something clear. Yeah. Here it is stations. So what they really, there is an example. So this example is, yeah. So first we start from Mangalore and to a junction. We don't know what junction is that, some X junction. From that, we want to go to Pune. So is it possible or not? So I want to start from Mangalore. There could be some station is there. There I can catch some train so that I can reach Pune. So that one I want to investigate. So first I get the train from the Mangalore. For each train, find the list of stations that goes. For example, Mangalore is there. We take the station Mangalore. This particular card, it belongs to Mangalore. This Mangalore, what are all the trains is reaching to the Mangalore station? We want to investigate. See, 02283, 02284. At most, both of them same. So 12223 and 12224 is there. This is also having, of course, up and down trains is there. So we want to investigate all of the trains which belongs to that Mangalore. And this particular train, what are all stations it is reaching? So this particular train, what are all the stations it is reaching? What really it is, it's a dictionary, and inside another dictionary is created. So with a list, I hope you got it. Again, it is another dictionary with a list. Another dictionary with a list. Another dictionary with a list. I hope you got it. Similar way,
Yes, sir.
same one, Pune is there. It is also having dictionary of train numbers with all list of stations it is going. So now first get the each train from Bangalore, for the each station a list of stations that goes. Similar way Pune also. So then after, what do you do? Yeah, of course it is. Here you can reach a station or junction Mumbai through 02283. From there you can reach that Pune. So using the train that 12219. So here what I did is, there is a train is there. So that train, using it, I can reach to Mumbai. Of course, maybe this train I can choose it from Mangalore to Mumbai. Maybe, of course, I check the dates and the day also and time also. So whatever the time it is reaching, and what is the timing of 122. Oh, okay, so sorry, it is Pune. From that, yeah, from that Mumbai, there must be a train. I hope you have to get it. So of course the train is yeah, I'm reaching that Mumbai. From the Mumbai, if that train is available from the Mumbai to Pune, so that I have to catch that train. Yes, yeah, of course it is. I have to check it that Mumbai junction. So does this part? Yeah, this train is, of course, it is getting into Mumbai. So when it is getting into Mumbai, definitely we can reach Pune. Yes, understood. Yeah, common station we want to find out it. This train is stopping at, so Madagon, Ratnagiri, and Mumbai. So I want to check it. Any train is matching to this any of three stations. Yes, Mumbai is matching. Maybe you might have 12223. It is matching to Secunderabad. So if you go to the Mangalore to Secunderabad, from the Secunderabad to Pune, you can catch it. The same train of 12219. Maybe other train is there, you can do in that. So this is what interesting data set, if you make a nested list inside a dictionary, this is what the advantage. So you can go to the one station, inside the station, one train. So one train, what are all the stations it is stopping? So this is what interesting data set, nested data sets you can make it. Still they are talking about, procedure to find that relationship among the customers based on the spending. So which is the 8.4 lecture. Here each record is processed by separate procedure. See here what they want to talk about is, until now what you did it is that simply just you write a single procedure, you update the dictionary, you write a single procedure, you update that list, update the list in the sense appending the item with a plus plus operator. Now what they want to do is they want to write a procedure. Each card is processed as a separate procedure and returns the sum of the items in the category, and return list is used by another pseudocode. So what you do is we try to give card to a procedure. The card of Advait we give to a procedure as input, and it will do some calculation and it returns some cumulative sum. Similar way, this Advait Abhinav has been said it. You write some procedure X. Let me think about the procedure X. This X is taking parameter of customer card, card or bill, customer bill. In this bill, it tries to compute how many food items is there. It is going to be computed and returns the count of food items count. This count is added to this initial 0. That's what is happening. Here, every time a new customer is created in the dictionary, add the category sum if the customer is existed. For example, already customer is existed. So we are trying to add it to whatever it's there. If it is not there, so simply what you do is just simply we update the value. So like, plus we do it if it is already existed. If it is not existed, simply we assign the value. So here we should be able to take the card of the sub procedure and return value. See, already we assigned, card has been taken as a parameter, and finally it returns one value, the computed value. But the problem is here, there must be a side effects. There is a conversation was done by interesting two professors. So one professor, what he wants to take is he wants to take each particular card and he wants to compute only the food items and returns that cumulative sum. The other professor, he wants to use it whatever sum he has been returned, so he wants to update it. That's what they want to do. I hope you understand that context in the lecture 8.4. Is it right?
Yes, sir.
Now there is a issue is found whenever you write sub problems, like you assign a work to somebody else, like you are a supervisor, you assigned a work to a mansion who is constructing a wall to a particular building. A particular building is there, so you are the mansion, so you give the directions to the worker, so that worker is constructing the brick by brick. So whatever you said, the wall should be in this measurement, all the stuff you said it. So you assigned it, he has to do it, and immediately he has to show the result. Oh, the wall is constructed by the today evening. Then there are side effects is there. So this side effect, sometimes it creates an issue, sometimes it is necessary, sometimes it is definitely required, sometimes it's not required. So I'll show you that. So one lecture has been shown. See, look at, compare two lists and find the overlaps. So overlaps in the sense duplicate elements. So wherever overlap is there. So here two lists has been taken, like L1 is taken, L2 is taken. So which is a list of elements, and this is also a list of elements. Each element of L1 is taken and each element of L2 is taken. Compare the equality. For example, so whenever you have a list of 7, 13, 2, and 4. I have that 16, 2, 43, and 30, for example. So let it be its unsorted list because they did not talk about sorting and exclusively they said it is unsorted. So now first element of L is taken, L1 is taken, compare with it. Is you find the similar element? No. 13 is taken, oh, yeah, it is similar element is found. Whenever similar element is found, immediately a overlap dictionary is created. The overlap dictionary is updated with 13. Now 2 is taken. Yes, it is found duplicate. Now 4 is taken. No chance of duplicate. Only 2 overlaps you found it between L1 and L2. That overlap you return. Now my question is, in this procedure, is there any side effect is there or not? Tell me. Did you find any side effect?
No.
How do you say no side effect is done here?
L1 and L2 are not changed.
Yes, exactly. We are not changing the values of that actual values of L1, L2. Using the copy values of the L1, copy values of L2, we build a new particular local variable which is called overlap, and that overlap is returned. Simple. Now no side effects here. Now let's we go for compare. Of course, if it is sorted list is there, so we need not start that inner loop from the beginning. Of course, every time the inner loop is started from the beginning, we need not start it. Take the help of first and rest. Of course, first and rest, if you use it, means first one we take it and remaining list we use it. Rest, if you take it, first one is avoided, remaining one. So that is sorted list. So of course, when do you use it, first and rest? They try to use it, inner loop is reduced in times of, outer loop is L1 times, but inner loop is repeated what, y is less than x and length of L2 is greater than 0 times only. Every time what happens, the size of the L2 is reduced. The size of the L2 is reduced, it means look at that. L1 I'm taking a list is 2, 7, 9, 13 and 43. So here they said it is sorted list. L2 they are taking another list is that 6, 9, 12, 13 and 21. This is something like, first what they did is, overlap dictionary is created. If length of L2 is 0, because you are comparing with L1 and L2, if that is empty, so empty overlap you return because you need not compare. Second list, if it is empty, you can say no overlap is available. For example, else what you do is y equal to first of L2. So y, what it will get is the first number. So y is getting that first number in the sense you get it 6. You get it. Now L2 will get it this part because updated list only you get it. Updated list in the sense avoided first element and you pick this part. You pick this part and it is updated into L2. So then what happens, you need not compare, you need to compare remaining only. That's what they did. Each element of L1 is taken and they compare, does y is less than x, is it y is less than x, and length of L2 is greater than, length of L2 is greater than is fine, but y value is there, it is not less than L1. So we don't worry about this while loop is executed. Then it comes, is it same? No, they are not same. Same loop is repeated. Same loop means what, at this time, this first time this loop is avoided. The reason is simple. Second list element is bigger than the first list. So now I need not investigate the next element because this list is sorted. If this is bigger, remaining all elements also bigger than the 2. Am I right or wrong?
Yes,
Hello?
sir.
That's the
Right,
reason
sir.
this loop is not repeated. Now 7 is taken from the L1. Then they try to check it. So whatever now y is there. So y is now it is again updated. Is it there? So still y is available with 6. Now it checks the condition. Does my y is it less than x? Yes. And length of L2, is it bigger than? Yes. Then what happens, now y is updated with recent update. Recent update means the first of L2. Now y is updated with 9. Now L2 is updated with remaining list. After this while loop is done, because it is 9 is there, 9 is not less than x, so this loop is exited. Is 7 equal to 9? No, definitely it's not equal. So what happens, so immediately overlap is not updated. So every time L2 is reduced and L2 is updated, like L2 size is shrinking, it is extended and it is going to be synced by using first is avoided, rest is taken. Now, is there any side effect is there?
Sir, could you repeat the last step
What is the last step here?
when you take the second y?
Yeah, second while, no? Yeah, second while is whenever this 6 is compared with 7, because 6 is compared with 7 next to x value, does my 6, is it less than 7? Yes. And length of L2 right now 4 elements is there, because this part, no? Clear? Is it right? Is it greater
Yes.
than 0 or not? Now it enter into the loop. In this enter into the loop, what happens, now first of this L2 means this is L2. In this first element means what? This is gone. Now recent y is updated with 9. Is it right?
Yes,
Is it
sir.
right or not? So that every time when you found it, that next element which is bigger than the x, the size of the L2 is reduced. Keep reducing, keep reducing. So that whatever the L2 you send it, the size of the final size of L2 will become 0. Is it right then? Is it right? First and last, first and rest.
Yes, sir.
Now, is there any side effect is there?
Yes, because
Yes, sir.
only L2 changed.
Where is the side effect, in L2 or L1?
L2, sir.
L2.
So whatever the actual flavor you sent L2, that has been modified. So once this procedure is executed, my L2 will become empty list after complete investigation of overlaps. So this should be a problem. So definitely it's a problem, because I have given a work to the particular mansion. I ordered him to construct it. He constructed, but he's not doing whatever the actual flavor I've given it, similar kind of flavor, he did not make it. But I lost it, whatever the data is, because I've written one copy of one particular copy as given it, and I've given a copy to him, that like written copy, something like that, a plan, it might be there. So whatever the plan I've given, he modified all the stuff. He has written on the plan, he has written all the things, whatever my plan copy. I don't have another copy also, so that I cannot recollect my things, what I sent as an input. That's the reason. Another overlap is there. This is updated version, overlap 3. What they did is interesting here is a local copy of L2 is created. See, look at a local copy. Fine. A local copy is created. So they don't
Yes,
want
sir.
to disturb that L2. L2 list is as it is. So whatever copy I've given to mansion, I suggested him to take a Xerox copy and bring back my original copy. Don't disturb it, because I cannot recollect the things what I given the instructions. So I've given a Xerox copy to him. So locally I made a copy and he given the original copy to BB. So remaining all operations are same. First of my L2, because all operations is doing on local. Rest of my L2 and length of my L2 and length of, sorry, first of my L2, rest of my L2. So here no side effect, because side effect is dangerous. So we avoid it with a local variable. So here it is definitely side effect is not advised. But sometimes side effect is necessary. See, look at in this case. Side effect is mandate. For example, See, we have a list of, sorry, a dictionary is there. In the dictionary, different values is there. For example, so we have student sequence number 17. So I have that is maths marks, physics marks, and of course chemistry marks is there. Sorry, it is 17, 18, 19, something confusing. So we'll make it some bigger marks. 78, 93, 43. And another student is there, 19. He is also having marks 46, 39, 59. So like this, you have list of students. So this is a dictionary with a key values. Key is 17, 19 sequence number. Now, intentionally, some student I want to delete because he might be detained or discontinued the course, this particular student. So now side effect is definitely required. So what I'll do is I will traverse each key in the dictionary. If key is not existed in the key, like whatever key you are trying to delete it, I want to delete the key number 90. So what my k value is 90. If key is not existed in the key, so which is not matching, so you are not matching it. So at that time, you get a copy of it. So that what happens, so you're trying to delete that K19, 17 is not matching to 19, maybe 18 is not matching to 19, these two are updated. 21 is not matching to 19, this is updated into my dictionary. My dictionary is a local dictionary. Except 19, all are updated. So that 19 is not updated into a new dictionary called MyD. Now this MyD is a filtered copy of this D. So again, what I do is, finally, I'll update it. So MyD is updated to D. So this is what, intentionally you did it. Is it right then? Intentionally you did it or not? Because I want to
Yes.
remove it from his roles. Whatever role book is there in my role book, I want to remove him. So simply, here the dictionary deletion of the particular key is necessary, so that we deleted it. So another example is there, without side effect also they've given. See, look at this is without side effect. It is deleted, but it is not updated. Simply we return it. We have not updated in D, just we returned it. But here it, you updated it into D. Whatever parameter you taken it, that is updated with after deleted copy. Here, the local dictionary is returned. The local dictionary returned means you get it into another local variable. So another local variable is taking MyD as a parameter, K as a parameter. You might update into MyD, or you might update that DD, a deleted dictionary. Something like whatever name you wanted, you can put it. The filtered copy you get. So here, side effect is you must know where it is really necessary, where it's not really not necessary. So sometimes it creates good, sometimes it creates bad. You need to take care of it really where side effect is. I hope you understand that. Clear?
86
Yes, sir.
divided.
Hello? Somebody wants to ask something? Yeah. So I'll go for ninth one. Just give me
Sir,
1 minute.
hello.
Yeah, tell me.
Sir, can you please explain in the previous pseudocode what my ID returns here? No,
MyD is a
sir,
local,
example 2.
local dictionary. It's a local. So local copy, we want to update it to D. D is updated with MyD. So it is
Okay.
updated. Local copy is updated to parameter. Updated
Okay.
to parameter. Fine.
Yes, sir.
So in this case, what they are not updating, they are returning. Whether you want to update it or not is your choice. Fine.
Okay.
So
Yes, sir.
whether you want to update it means same parameter name, I use it for same variable. But I don't want to update it means what I do, a temporary dictionary equal to delete key to with my d. So what happens, it will take my d and k, it doesn't disturb my d, it returns a copy into td. This td you can use it for other purpose, or you can do it again my d equal to td. That is your choice. Clear?
Oh, okay, sir. Yes.
Yeah. Yeah, just give me 1 minute. Huh? We'll go for the ninth week. Yeah. So now this ninth week is a new concept is introduced. Graphs. Let me go for the graphs. So it is unstructured, it is unstructured data structure. What we call, it's not a linear, it's a non-linear one. So linear means what, it is sequentially we go, like, so 1 to 2, 2 to 3, 3 to 4 in that way. But when it comes to the graph, it's a non-linear data structure. So in terms of non-linear, what it senses, first student related to that 17th student, 17th student related to 13th student, again 13th student related to first student, something like that. So what you call, graph data structure, it is a non-linear data structure. First you understand, it's not a linear. Till now dictionary it's a linear, list is a linear, but when you combine this graphs concept to the dictionaries, so then it is called non-linear. Let me understand relationship between two students. So every student is,
Sir,
yeah, yeah.
sir, just can you explain once more that non-linear? My connection got a little disturbed.
Say, look at, so here the 12th student is there. For example, we are thinking about linear. So this 12th student is having a sequence of information, like, sequence of information means maybe got that 78 marks, 72 marks, 32 marks, and 13th student is there. So he is having 87 in maths, 41 in physics, 31 in chemistry. So till now what you do is, this is a dictionary and this is a list. Till now what you did it is, you want to traverse the list from, dictionary from top to bottom, of course from first key to last key. Similar way, the list you want to traverse from left to right. This is called linear data
Okay.
structure. Sequentially we go, either it is top to bottom, you go for that left to right. Now when you come to the non-linear data structure, non-linear, so we want to make it some particular students in a kinds of relationships. 12th student, he might relates to the 13th student, 13th student related to 7th student, again 7th student related to 12th student. So what way they want, they are related. So there are different features we need to consider. Maybe they related in terms of maths marks, they related in terms of physics marks, they related in terms of chemistry marks. That is been represented. How this can be represented? We should require a data structure. That data structure is called graph. Of course, graphs internally using dictionaries, but it's a non-linear data structure. Internally it is using dictionaries only, but it's a non-linear data structure. Non-linear means 12th student knows about 13, 13th student knows about 7, 7th student knows about 12. In some kind of concern, we'll understand what kind of concern is. That is called non-linear.
Okay, sir.
Now, yeah, this relationship we want to find out and we want to store it in the database. So like, in the computer you want to store it, in what format I can store it. This graph is there, We cannot store it like a graph, means like directly a graphical image, because if you store it as a graphical image in the computer system, there should be some calculations I want to do. Calculations we cannot do in the images, so we require some arithmetic data or some kind of digital data. So that's the reason numerical data you require, so you maintain like another kind of data structure called graph data structure. Now let us see student A relates to B in terms of some subject may be math subject. Maybe the student A got higher marks than B in terms of maths with a minimum difference of difference between 10 to 20. So minimum is 10, maximum is 20. This scaling they fixed it in the lecture. The 11th student, he is relates to other student of 7, 16, 6 in maths. So definitely if you compare, the maths marks got by 11 is definitely greater than 7th student, 16th student, 6th student and other students with a difference of 10 to 20 before, maybe 15 marks, 16 marks or 10 marks or 11 marks. Similarly, student number 1 is there. He is having higher marks than 3, 12, 24 students in the subject of maths. Is it clear? Is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now this particular relation is there, no? This relation is, they are making a directed one. They are making as a directed one. So this is what called direction. So what exactly means that, the 12th student, he got higher marks than 13th student in the subject of maths. Similar way, the 7th student, he is getting higher marks than 13, maybe in terms of physics. Similar way, the 12th student, so he is getting the higher mark, he is related to 7th student, maybe in terms of chemistry, or it might be maths also. Maybe the maths also, because 12th student may be better than 13 and 7 in terms of math subject, or it might be chemistry subject, even physics also, because you have that one-way direction only. Same thing is applicable for physics and chemistry, means that sequence number 11 having paths or edges to 6, 7 and 16. See, 11 is having 7, 6, 6 means 7, 16, 6 means the 11 is better, got the better marks than the student 7, 16 and 6. Now, based on these things, whatever you learned, this particular investigation, you need to understand this. What is graph data structure? The graph data structure is a non-linear data structure. It can be used to represent the relationship between the students. That's what the definition. I hope you understand. Is it clear?
Yes.
Yes, sir.
Now,
Yes, sir.
yeah, now construct a graph data structure from a list. So if you want to construct a graph from a list, that means 11th student, he relates to that 7, 6, 16 means you supposed to make 11 and you need to construct, he is related to 7, he is related to 6, 16, he is related to 6. So this entire one is a graph. Of course, this relation is based on maths marks. Yes, using the list, we can construct a graph. Now, define node or vertex and edge. Here, node is nothing but 7 is a node, 16 is a node, 6 is a node. Sorry, I missed that directions because it's a directed graph. This is a direction one because 11 is better than 6. 6 is not better than 11. So now these are called nodes, or you can say that vertex. What are all edges? This blue color things are edges. Maths, maths, maths. These things are called edges. So we understood what are nodes and what are edges. Now, assign the directions and labels to the edges. Yes. So the direction, you must be very clear about it. Who is better than who? So that has to be identified with a forward arrow, or it might be a backward arrow. Sometimes 7 is better than 11. You might show it in reverse direction also, not issue there. So that directions are there. And similar way, edges are having labels. These are called labels. You know, the relation is based on what kind of subject you have been using for relation. And advantage of drawing the graph data structure is you can find out the students who are different students, who are similar students. You can easily find out, oh, these students are similar kind of students, these students are different kind of students. So that's what the advantage of working with graphs is. I hope you understand graphs introduction. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now this graphs data structure you have to convert into numbers. You have to convert into a digital data, like zeros and ones and zeros and ones. So that is only the thing. So how can you make it zeros and ones and zeros and ones is using a matrix. What this called, this matrix, you know, adjacency matrix. This called matrix is called adjacency. So don't worry, this adjacency is a new word. It is a called neighbor. So it shows you that who are all neighbors. For 11, who are all neighbors is 7, 16, 6. Okay. But 7, it's not the neighbor. You know, 7, you cannot do a reverse kind of comparison because it's a one-way direction. You did not do the two-way direction. If two-way direction is done, that is a different one. It's undirected graph. But right now, it's a directed graph only. So we do that adjacency matrix. If a two-dimensional array, we can take it. M number of rows, n number of columns. Random access, that's matrix of mi. You know, ith row and jth column. By convention, we can call it. Always it is numbered from 0 to I and m minus 1. For example, 5 rows is there, 0 to 4, because it is m minus 1. Similarly, 5 columns is there, 0 to 4 columns. This is the rows and these are columns. So don't worry, rows and columns, what are all these are? This is simply your vertices. What are all your vertices? Same number of rows are created, same number of columns is created. So if 5 particular vertices is there, I hope you understand. These are all vertices, no? Did you notice these are all vertices?
Yes, sir.
Yes.
So how many
Yes, sir.
vertices? How many vertices is there? Similar number of rows are created. Similar number of columns are created. Always it is n square matrix. What is this n is? Number of nodes. This is a simple thing. Please, you can remember. It's a blind rule. Is it clear?
Yes, sir.
Now, how to create the matrix? So it's very simple. See, look at creating the matrix is very simple. They are creating a matrix.
Please
Yeah.
just repeat once what
Hello?
the n square is represented.
Yeah. N number of rows. See, if you're in your graph, 3 nodes are there. 3 vertices. Then what happens, you know? The matrix is created. 3 rows and 3 columns. Is it clear?
Yes, sir.
Let me consider your scores data set. How many cards are there?
30.
30. So then using 30 cards, if you create a matrix, how many rows, how many columns are created?
30 rows and 30 columns.
Exactly. 30 into 30. Simple. Because we want to find out the relationship between the student, means you might have to find that each student with other student in terms of graphs. So that if n cards is there, n into n matrix is created. I think it's clear. Is it right?
Yes, sir. So basically, the number of nodes would be n square, right?
Exactly.
Okay, sir.
So here n means the number of nodes. That's what I said. It is, you know, n means it's a number of nodes. This is what number of nodes. So here nodes in the sense number of cards, simple. So now how to create this matrix? To create the matrix, they are trying to use it a dictionary. So why they are using dictionary is random access is possible. The ith row and jth column quickly you can access it. What exactly ith row, jth column is, this is 0 0, this is 0 1, this is 0 2. Then what is the index position of this? This last one, can you tell me?
2 2.
Exactly, 2 2. What is the index position of this?
20.
2 0.
Exactly, fine. So this way you want to access it. That's what the thing they are. Initially, it's a empty dictionary is created. Initially, I value is 0. I is repeated rows number of times. And then matrix of I is created empty one. What happens, this is a dictionary inside this empty dictionary. Of course, this empty dictionary is something like a bigger one. Initially, it started with a big empty dictionary. Row number of times we are creating the first row. Of course, it's a first row and a second row and a third row. Is it right? Because that every row you are creating, that ith row is empty dictionary. Again, in the each particular row, in the column, what I'm creating is again dictionary. So that this one 0, this one 0, this one 0. Similar way, all this is zeros. Initially, all of them are zeros. I hope you understand. Fine. Fine.
Yes, sir.
So that what happens,
This means
initially,
the columns are the list within the list of rows.
no, no, no. Dictionaries with dictionaries inside.
Okay, okay,
Okay.
okay. Yes,
Dictionaries inside a dictionary. It's a big dictionary. The big dictionary is, I'll make it as a green color. I'm sorry. I'll make it as a green color. This is my outer dictionary. Yeah. This is my outer dictionary. This outer dictionary represents this entire one. Clear?
yes, sir.
Now, another inner dictionary is there. It might be in orange color. This one. This is called each row. Fine.
Yes, sir. Yes.
Now the red color things are there. This is what the value inside. Zeros is there initially. All of, sorry, red color. Huh? Yeah, I'll put it zeros. Yeah. Zeros. Oh. Initially zeros.
So here
All
the
these are,
zeros denotes the rows, na? So
no,
rows are all.
zero represents that cell value at 0th row, first column, 0th row, 0th column. Because
Okay, okay. Yes.
you are trying to initialize here. See, ith row, jth column. Fine.
Yes, sir. Yes.
So that all rows, all columns, initially it will put it zeros. So that is returned. A newly created matrix with n cross n size. Initially, all values are zeros. I hope you understand this procedure. Fine.
Yes, sir.
Sir, can you give example?
What is the example here? See, if 30 cards is there, you send the size of the cards is 30, then the big matrix is created with 30 rows, 30 columns. All students are initially zeros. They don't have relation with other students. Fine.
Yes, sir.
Sir, excuse me, sir.
Yeah.
Why that value should be in dictionary? Since it is don't have any
Because
key
because
value.
because list is only sequentially traversed. No random access possible. List is only traversed sequentially.
If there is an dictionary, then it will be an index
Dictionary
and
can be
key value.
directly accessed by key value, just key, random access.
How it can
Fine.
be
Sir,
the value in the key
sir,
value? Where is the index then?
sir, I believe she is asking
Wait.
that why in the dictionary you have given the value, why not the key? I believe she is
Yeah.
asking for that.
Yes. Yes, you are right.
Okay. You are asking this one. Value. You are asking.
Yeah.
This one.
Yes, sir. Yes.
So this key is already mentioned. No, ith row, 0th column is the particular one. See, you are sorry, you missed it. I'm sorry. Huh? So maybe I have to give it something expanded format. So what I supposed to give is here, 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 here. So what I supposed to mention is the orange color key is 0. Here orange color 1. Orange color 2. These are rows. Is it right?
Yes, sir.
So this particular key is having, again, you have a dictionaries, this is. Inside of this, again, dictionary is there. Is it right then?
But key value and
Wait.
that
Here key is satisfied, no, or not?
key is
Here,
satisfied. But
now,
why the
now, now,
value
now,
is inside?
let me go. Let me go for. Let me wait. Let me wait.
Okay. Okay.
So in this, what happens? Again, nested dictionaries are there. Each one requires again key and value. Am I right then? So what I'll do is, again, in this one, I'll do that erasing of this. Sorry. Yeah. Yeah. In this also, we have a key and value. Oh, sorry, one missed it. Don't worry. Other things also similar. Yeah. So what I'll do is the red color I'm taking. So inside what happens, yeah.
Sir,
Inside what happens?
shouldn't the zero
Wait,
be
wait, wait, wait,
outside
wait,
the
wait,
yellow
wait.
value?
Let me complete, man. So now inside of this, sorry. Yeah. Inside of this, 0 is created with 0 value. 1 is created with 0 value. 2 is created with 0 value. I hope you understand now.
Yes, sir.
Yes, sir.
Yes, sir.
Similar thing is happened here. Can you tell me what is index function? Just now you said 0 0 0 1 0 2 is over. 0 0 0 1 0 2 is over. Now tell me what is here.
0,
10,
0
Zero,
1,
zero,
1, 1,
0 0.
1,
It's a
0,
1
one
0.
zero,
then 2,
Same thing,
0.
same
two
thing
zero,
like
sir.
It's again you get 0 0. 0 is the key, 0. But all of the values are zeros because initially they said it's zeros. That's the thing they did it, nothing else. No magic here. I hope you got it.
yes,
Yes,
sir.
sir. Yes, sir.
Yeah, fine. Now it is
Yes,
pretty
sir.
much because why we use the dictionaries, quick accessing is possible. For example, directly second row, third column I wanted, I can directly mention second row, third column. Sorry, second row. No, I am sorry because it is 0 to size minus 1 they said. Second row means it is 1. Fine. Third column means 2. So second row is this. Third column is last. Third column means this one. So you get the value. You get the value means 0. I hope you got it. Okay.
Yes, sir.
Yeah, this is enough. But this procedure, whatever you created, this is used for all other procedures. Like whatever procedures they are writing, they try to use the same thing for others. They want to call this procedure. So they want to call this procedure create matrix, create matrix, create matrix. So in the next next procedures they are trying to utilize it. See, look at.
Excuse me, sir.
Yeah,
Sir,
tell me.
can you please scroll down, sir?
Yeah.
There. Here, why did you initialize 0 to mat of I?
Initially everybody is independent, nobody related to others, because we did not do
Yes, sir.
investigation. No, we did not do any
Yeah.
investigation. So that's the thing,
Yeah.
initially all of them zeros.
Okay. Okay, sir. Thank you.
Fine. As and when
Yes,
matrix
sir.
is
Fine, sir.
created, yeah, so this matrix is for initialization, just like a equal to 0 you are taking, initial matrix is 0. Now
Okay.
how to iterate the rows and columns is always rows and columns are in sorted order, so we don't worry about it. So that's the thing, sorting is enabled, we don't worry about it because already they have been initialized with keys in the sequential order of rows and keys in the sorted order of columns also, so we don't worry about it. For reliability means for easy understanding, instead of write sort keys, instead of two functions, they are trying to write for easy understanding rows and columns. Rows will traverse rows values, columns will traverse columns value. I hope you understand. To improve readability only, they try to use directly two functions, rows and columns, for easy reading.
Yes, sir.
Okay.
Yes,
I
sir.
hope you understand. Now we are trying to build that undirected graphs with clicks. So what exactly undirected graph with clicks is? Similar kind of students, we want to make them as a group, like mutually A is helping B is helping A. So what exactly, A and B is there, no direction. So directly A and B, there is a relation is there. Maybe A is helping to the B in terms of maths marks, and B is helping to A in terms of physics marks, maybe then. So in that case, what do you say that, it is an undirected graph, undirected. So A could mentor maths A could mentor B in maths, B could mentor in physics. So in that case, we cannot show the graph like this. So A to B, then again B to A. So this way we don't want to represent. Simply we want to represent with undirected graph. Clear? Clear then?
Yes, sir.
Yes, sir.
Yes, sir.
Now, yeah, all connected students who call them, like, they are connected, do call them as a group. Let's take an undirected graph, A to B, then. So B to C, so again C to A. So this way. These kind of students, what you call them, these things we call them as a clique, or we can say that group. Some way they are related. Always they are, some way they are related. Maybe A is mentoring B, B is mentoring A, C is mentoring A, or A is mentoring C, something like that. They are completely, they made like one group of friends, one group of students. So you understand this concept. Okay then, fine. So cliques we can build only in the undirected graph. We cannot make cliques in the directed graph. Fine. Fine then.
Yes, sir.
Yes.
Yes, sir.
Now, concept of popular student is that. This is what another kind of concept, which is earlier concept of 9.3. They try to identify the popular student. So when do you say student is popular as if and only he or she can help other students or get the help from other students. Both the things are allowed. Like if it is A to B is there and A to C is there, A to D is there. So let it be a directed graph. I want to make it as a directed graph. So in this case, who is popular?
A.
A is popular in terms of mentor, because he is mentoring multiple students. Similar way, another example I'm taking. So here E is there. E is getting help from D, he is getting help from B, and he is getting help from that E. So then who is popular?
A and E.
So A is popular in mentor and E is popular in mentee kind of way, because he is getting help from D, B and C also. Maybe he could be average or below average student. In that way also he is a popular student. That's the reason they said, either he can help other students or he can get the help from others. In this way the student is popular, because as per the lecture they said it is who is popular means whether he is helping other students or he is getting help from it. Now one thing you should
Excuse me,
understand.
sir.
Yeah, tell me.
Sir, can you please explain what a click is?
Clique is similar students, we want to make them as a group. For example, A, B and C. They are making like a one undirected graph of cycle. This thing. So in this, what you know, it is undirected one. Maybe A is helping B, B is helping A. A is helping C, C is helping A. So C might help B, B might help in C. So in this case, we can make it a clique. Is it right?
Yes, sir.
For example, if you make it A and B and C as a directed graph, I don't want to make it undirected. We can't make them as a clique because they are not similar. Always A is helping B and C, B is helping C. How can you say that C and B is same? No. Fine. Is it right
Yes,
then?
sir.
So C and B is not same. A and B also not same because B is getting the help from A. But A is not getting the help from anybody because it's a directed graph. So now take a pool or set of students or cards, find the mentor and mentee relationship between the students with a minimum difference of 10 to 20. Like, you know, so one student you take it, you compare with other students. So in terms of a particular marks, you know, like you take a maths marks. So the difference between this particular student to other student is 20, 10 to 20. Minimum is 10 and maximum is 20. Then you can make the edges. Like A can mentor C and B and D if and only the maths marks difference is minimum 10 and maximum is 20. That means too high is not required, too low is not required. That is what we want to make it. Until this context 9.3, 9.4, all these they want to make you to understand what is the context. We want to write the next procedures. If you permit, I'll go for the procedures now. Coding part. Shall I go then?
Sir, in and out degree, can you explain?
What is that? What do you want?
Sir, in and out degree.
Yeah, in and out degree. Yeah. So here, see, look at in this case, in and out degree is not there, just degree because it's an undirected graph. Fine. Is it right? Now,
Yes, sir.
degree of A 2. Is it right? Because incoming and outgoing also 2. So we cannot say in and out, just degree. For example, a directed graph is there. In this case, see, look at this graph is there. So here, in degree of A, tell me what is the in degree of A? It's 0. Fine, because A is not getting the help from anybody. Out degree is there of A. What is the out degree then?
3, sir.
Yes,
3.
3, yes. So in and out degree is a separate degrees when it is a directed graph. If it is undirected graph is there, it's a degree only. We cannot specify exclusively this is in degree and this is out degree. I hope you understand.
So in case
Okay.
of undirected graphs like clicks, we can say that the number of in degrees is equal to the number of out degrees.
Exactly. It's a degree only. It is same. Both of the in degree and out degree same.
Yes,
Because
sir.
both of them are benefiting. Like A is helping in B, B is helping A. Clear?
Yes, sir.
Now, this procedure you remember, this procedure is always used in upcoming procedures. Create matrix, create matrix, create matrix. Before they are constructing adjacency matrix, first they create an empty matrix with all zeros. Later they try to use it. So this is 9.5 is exclusively talking about procedures. Yeah. From 9.5, they are real-time examples they are taking using graph. Just give me 1 minute. I'll give you water then. Yeah, set back here. So all the upcoming procedures are taking the help of the create matrix. So every time when the create matrix is there, you simply recollect that There are the rows and columns are created in terms of dictionaries. So you remember it. That's what fixed. Yeah. Now create a dictionary for the marks of a subject. So maybe any subject. You want to create a dictionary of maths marks, you send maths as a parameter. You want to create a dictionary of physics marks, you create a physics marks. So this is a general call. Of course, you can say that interface. Once you call this one, what happens? Simply, it will go to a local dictionary inside a procedure. This is a calling procedure, this is a call procedure. Already you know interfaces. Who is calling? Here we are calling. Once you called, what is happening? Inside the procedure, a local dictionary is created marks. A table is reading, each particular mark has been reading. So first card we read it. So this first card sequence number is updated into marks, so that this a big dictionary of marks is created. So in this, the first student is math marks is updated with x dot subject. So this x dot subject means what subject name you sent as a parameter. So this subject may be maths, means maths marks is updated. Similar way, second student, his marks is updated. Third student, his marks is updated. Of course, all this is that a particular marks dictionary, which is the subject you sent it. If you send a subject of maths marks, it creates a dictionary of maths marks. So that is returned. See, that is returned. See, after creating it, it is returned. So the returned one, is updated to another variable called maths mark. So this maths marks is going to be the updated dictionary. So here it is. Yeah, maths marks. I hope you understand this procedure. So this procedure is returning maths marks as a dictionary. I hope you understand, no? Is it clear?
Yes, sir.
For example, you create a dictionary of physics marks. A dictionary is created with physics marks with all sequence numbers of the student, 30 students with 30 marks entries. So definitely 0 to 29 is there. Of course, I have taken 1 to 2, not a problem. Now creating a mentoring graph. Who are eligible to mentor whom? Who are eligible to mentor whom? So with a specific condition. We'll see what condition is. Look at, if I of j equal to 1 means there is an edge between I and j. So that means first student, second student, third student, fourth student, fifth student. Of course, 0th student also I'm taking, because our sequence numbers is having 0 also. Whenever there is a 1 you are specifying, means there is a edge between 0 to 1. That is represented with adjacency matrix. This could be adjacency matrix. Let me take only 3 rows and 3 columns, because I don't want to make it complex there. So all rows and columns are same. 0, 1, 2. Of course, this is something earlier. I want to make it, it is 2. So I don't want to take it, other things, because I don't want to make it confuse, Just only 3 students. Clear? Yeah, pretty much then. Yeah. Now, whenever you take 0, 0 to 0 is not possible, because we don't want to create a cycle like this. I don't want to create cycle like this. So that's what I think, always 0 to 0 is 0. For example, there is an edge between 0 to 1. How can you represent? A non-zero value. A non-zero value, preferable value is 1. Fine. Fine?
Yes,
Is it
sir.
clear?
Yes, sir.
Now, 0 to 2, is there any edge? So no edge is there. So let it be. Already graph looks like this. 2 to 0 is there, and 1 to 2 is there. Let it be like this. So 0 to 2, any edge is there? No. So definitely it's 0. Now, so 1 to 0, any edge is there? 1 to 0? No. 1 to 1, definitely it's not there. We don't worry about it, because itself is not possible. 1 to 2 there is edge, yes. Now 2 to 0 there is edge, yes. Now next one, 2 to 1 there is edge, no, definitely it's not there. 2 to 2 definitely it's not there. This is a directed graph. I hope you understand. Fine.
Yes, sir.
For example, undirected graph we are taking. Same kind of pattern. Same kind of pattern. But it is undirected one. So what happens, they are related, both of them, in terms of something. I don't know. 0 is helping 1. 1 is helping somewhere in the 0. 2 is helping 0. 0 is helping 2. So in this case is the adjacency matrix, it looks like this. Same 3 rows and 3 columns. 3 rows are there, 3 columns is there. Of course, space is somewhat not sufficient. Same 0, 1, 2, 0, 1, 2. Fine. Now 0 to 0 is not, definitely it's not there. 1 to 1 also not there. Let me fill this one zeros first. So this 2 to 2 also not there. Now 0 to 1, yes. 0 to 2, yes. Now 1 to 0, yes, because 0 to 1 means definitely 1 to 0 also there. When you find the 0 to 1 there is a path, definitely 1 to 0 is a path. Similar way, 1 to 2, yes. So then 2 to 0, yes. 2 to 1, it says. So that they are calling, vice versa, they are helping. So you have to represent that more number of ones, because they are not directional one, they are undirected. So that's the thing, a non-zero value should be there. Always non-zero value we prefix with, we store it like 1 only. Zero value means no edge is there between the I and J. I hope it's clear, no?
Yes,
Is
sir.
it clear? Yeah.
Yes, sir.
Yes, sir.
Yeah, it's a fundamentally it's true. Now, how the mentor graph is created?
Yes.
So already I said the mentor graph you required if and only minimum difference is the 10, maximum difference is 20. So we consider that condition only. See, look at
Excuse
here.
me, sir.
Yeah.
I have one general doubt, not based on this graph.
Hmm.
Why we are generally taking the values from 0 to n minus 1? Why not from 1 to 1?
No, it is actually the upcoming programming languages which you are going to learn. They always use it from 0. For example, in diploma level, you learn that Python. Is it right?
Yes.
Foundation level or diploma level? Hello.
I am in foundation only.
So in foundation you have Python, or diploma level you have Python?
In foundation.
Foundation.
In foundation level, if you next time you choose the Python always the index position start from 0 only. Even you go for the next language like Java, always index position starts from it. In degree level you have Java. So that's the reason, the similar kind of way they framed this course is always from 0. That's it, nothing else.
And I have also another doubt that whether that a create matrix and like a create mental graph like that, it is a fixed term or whether we are creating like that.
No, we have created, the scenario is created by the professor, and the same scenario they are using. That's the only thing.
But
So
whatever the
yes,
that is what
there could be that instead of mentor they can create in real life, review kind of graph. One particular customer reviewing product, another customer is reviewing same number of reviews to the same particular movie. In that case, the graph name you can put it mentor graph. Similar way you can make it review graph, something like that. Fine.
Their understanding, our understanding, we are creating that.
No, because our data set is students data set and scores data set. They created mentor graph, or you can say that instead of mentor you can make some other word, not issue. Clear? Okay. Yeah. So now look at here, initial variables they want to set it. Initially, how would you know that how many number of marks entries is there? See, look at already marks is already created as a dictionary. See, look at here. Already I said it, no? 30 maths marks is there, 30 physics marks is there, 30 chemistry marks is there. Is it right then? So now length of the particular marks we got it. Let it be, we want to create mentor graph for maths. Now the length of the keys of maths marks you are getting. So 30 we get it into n. Fine. Now create matrix, it creates 30 into 30 rows and columns matrix with initial values of all zeros. All zeros. 0, 0, 0, 0, all this. Is it clear up to this one? Is it clear?
Yes, sir.
Now they are trying to traverse whatever empty matrix is created. This empty matrix is called as, so mentor marks. Sorry, I think it is something mistake was done. It's a mentor graph is there. This mentor graph they have to traverse, but it is they're traversing it is yeah, it's
So
okay.
actually, they have used a general graph
Yes,
as
yes, yes, yes.
the
Understood.
Marx dictionary, sir.
Yes, yes. Understood. Understood. So this might be that keys they are extracting. The keys is extracting means maybe the maths marks is having like a 0th student 76, first student 71, second student 67, third student 86, something like this. For example, you take it. It could be maths 1. We try to traverse each key from the marks and you compare with remaining student. When 0th student is taken, you compare with 1, 2, 3. First student is taken, you compare with 2, 3. So second student is compared, you compare with 3. I hope you got it. No, this is what outer loop and inner loop is. In this, the difference they are calculating. First, they calculate difference between 76 and 71. Then they are trying to compare 76 with 67, 76 with 86. That is what first cycle. So that difference we get it. What's the difference we get it? 76 and 71 is 5. If it is minimum, it is 10 and maximum 20. We make that particular path is 1. That means you are able to 0th student can mentor first student. I hope you got it. Is it right?
Sir,
Tell me.
sir, in this, but first time we, what value we take for I?
I is that's one, no? 0, 1, 2, 3. Because keys, same keys are repeated in marks. This is a Marx dictionary. It's a nested one. Already, pair of students you are finding, same thing they are doing. First student compare with remaining 29 student. Second student compare with remaining 28. That's what happening. Nothing great here. Clear? The difference is calculated. The difference is calculated. Local variable. If the difference is minimum 10, maximum 20, you make a mentor graph. This mentor graph is there, no? This mentor graph, so this makes I can help J. So that means 0th student can help J. So that is what, directed graph. Sorry, here it's a directed graph. 0th student can help first student. But right now, this case is not happening because difference is 5. When you come to 76 and 67, what's the difference? 9. So they cannot help. When you compare 76 with 86, is it right? 76 with 86 is there? No?
No.
Yes, sir.
The difference is there. So there is a difference between, sorry, it's a negative value. Sorry, it's a negative value. This way also it's not possible because they did not use absolute value. 0 cannot mentor 3. 3 can mentor 0. I hope you got it, no?
Yes, sir.
So that's the reason at this case also
Yes, sir.
0 to 3 also it is 0 only. After that 1 and 67 compare. It's not happened. But when you compare with 86 with 76, 86 can help 76, 86 can help 71, but 86 I think it is 30, 19. Yeah, 86 can help the student 3 can help 0th student, first student and second student also. What is happening, 0, 1, 2, 3 students are there. In this case, what happens, this third student can help first student, he can help second student, he can help zeroth student also, because 86 to 76 difference is 10. That's the reason you can help. Fine. Hello.
Yes,
Yes,
sir.
sir.
So third student can help 70, sorry, first student also, because the difference is, so it is 15, clear? And this is 90, 67 and 86 is 19, sorry, 18, no? Yes. Because we can consider up to the 20 difference. But 0 cannot help third student, because we want to compare that exact difference, not absolute value, not like, absolute value. So in that way it is constructed. The constructed mentor matrix is written. Whatever matrix is constructed, that matrix it returns back. I hope you got it. Fine.
Yes, sir.
So
Yes, sir.
up to here, please make it available. I'll this particular things I'll forward to the next session, because 9th and 10th sessions and 11th sessions are linked. If and only you remember this adjacency matrix, how it is created. Is it clear?
So,
If you are cooperate that, I'll complete the fourth page also. Is it okay?
Sir,
Yeah, tell me.
sir, I have a confusion in this. Sir, in this pseudocode, there
Hmm.
are for each I in case. So
Hmm.
here, uh, the first will be compared with second, and the second will
Hmm.
be compared with third. So
No, no, no,
how?
no, no, no,
Uh,
no, 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 no. First will
yes,
be compared with remaining all. Like means first is compared with first. Zeroth is compared with first student.
yes,
First. So see, look at yellow color. I made it. No, that means zeroth one compared with remaining three. Now I'm making green color. Green color is exclusively made it for first student compare with second. First student compare with third. Fine.
yes, sir.
Now red color I am making. Second student compare with
Three.
third student only, because
Okay,
already second student compared with first student earlier. Outer
okay,
loop,
okay,
inner loop, no, that's what is happening. It's already, pair student you are finding, the same kind of loop. Outer loop it takes first student, inner loop it creates n minus 1 comparisons.
okay, okay.
That is same
Yes,
thing
sir.
here, same thing here. Clear?
Okay,
sir,
sir. Understood.
Yeah.
Sir, just one
sir,
point.
Hmm.
Then, sir, that last three we are not comparing. That means we are already
Compared,
covering that.
no, already we are compared.
Okay, okay, sir.
Zeroth one we compared with remaining three. Then when you start first one again you not compare with zero, no?
No,
sir,
no,
sir,
sir.
it should be compared now, because then it
Why,
will
why,
become.
why, why then?
Sir, I think for the first case, I will be 0, and
Hmm.
J will be 1, 2, 3. J will be 0, 1, 2,
Wait,
3.
wait, wait. First zeroth student is compared with remaining three. Clear?
With sir,
Zero
with
is
0
compared.
also, no?
No, no. Zero is not compared. Why zero is compared? Zero
Sir,
is
because
compared with first. Ah.
I are rows and J are columns.
Hmm. Okay.
So same number of if there are 30 cards, so I will have, if there are entries like in I 0 to 3, so J will also have entries like 0 to 3.
Yes, sir.
What
I
happened?
believe, sir, because both I and
Okay,
J
okay,
can
okay. Sorry,
take
sorry, sorry, sorry,
that
sorry.
zero
Yeah,
from
here
that
it is.
end.
Yeah, again, that same marks is okay. This could be a mistake. Yes, you are right. You are right. So maybe again zero to zero also compared, but it's not
Yes,
right
sir.
actually.
Yeah,
This
it
is
will be 0, but
yes,
as we cannot compare, but
yes. It will be zero, but it is no way it is concerned. But actually, it's not right. Fine. You are understood. Understood.
Sir, that means, sir, just interrupting that, for each I in keys of marks and for each J in keys of marks, then we are comparing each of I with each of J. Then
Yes, yes.
everyone is
See,
compared with everyone.
yes. I is zero is compared with zeroth one. First one is compared with first one. Second one is compared with second one. Yes. All right.
sir, so it will go like this, no? 0 will compare with first with
Yes,
0
yes,
to
yes,
3, and
yes.
then 1 with 0, 1 to 3.
Yes. See, that's what the thing. Zero is compared with zero, and then four times comparison. So similar way, this one is that green color. One is compared with one. Okay.
1 with
Then
0, sir.
oh, sorry. One is compared. Yeah, it's right. It's right. One is compared with 0 also. Yes, because
Yes,
again
sir.
j is repeated. No, understood.
Yes.
Understood. Yes, yes. It is uh, n square times it is doing. So everyone is compared with other one. Yes, you are
So
right.
then one with 0, one with
Yes,
1,
yes,
one with 2, one
yes,
with.
yes, yes. You are right. You are. Of course, it is a time complexity concern. You don't worry about it. Yeah. Of course, same difference you get it, but it is a time complexity. Yeah. Now, now pair of things you want to find out. See, look at here. They want to do it pair of students, like maths marks pool of students is there, physics marks pool of student is there. A might help in B in maths, B might help in A in physics. So that's what somewhat extended. So what they did it, same procedure. They called for maths. Same procedure. They called for physics. Now two dictionaries are created with math marks dictionary, sorry, and physics marks dictionary. I hope you got it, no, these two.
Yes, sir.
Yes, sir.
Now mentor graph also created. See, look at the mentor graph already created. So first they are creating mentor graph for maths, then they are creating mentor graph for physics. So what exactly, from A to B, whether the help is going on in math subject, A to C whether the help is going to in maths marks, A to C whether help is going to maths marks. Similar way, B to A maths marks is going or not, B to C going or not. That's what investigated, and based on 0 and 1 is created. Same thing is happened. Now paid they are checking. They are checking paid. So whether they are paid or not. So what exactly paid? Both of them getting help with mutually or not. That means what that is A is helping in maths. This is maths. Similar way, B, see, this could be the B. B is helping A in physics. So this kind of thing, what do you call, paid. Both of them are helping mutually each other. So at this case, what they created, another paid kind of thing they created. It's a local dictionary is created. This is a local dictionary. This local dictionary, what it will do, it will create paid of I equal to j, paid of j equal to I. So what it will create is, sorry, it will create dictionary. This dictionary is updated. This dictionary is updated. Paid of A with a value of B, and paid of B with a value of A. That's what simply it's happening. I hope you got it. Clear?
Yes, sir.
So that is what it is happening. Whenever a pair is there, so at that time, so whenever this particular, both of them are equal to 1, and this key is not existed, A is not existed, B is not existed. So whenever that key is not existed, simply we'll update it. For example, already this key is existed, we don't want to update it. So we don't do any operation because else part is not given. No? Here else part is not given. So whenever else part is given is something like you do increment and appending of the list. We don't do that appending and incrementing of list. Simply we update
Uh,
that. Yeah.
sir,
Tell me.
sir, just interrupting. So for that only, that if condition, where
Expanded.
we have written maths, mentor graph, physics, we have used that and condition,
Yes.
and not is key, and not that
Yes.
or condition, so that they must not be paired previously, so that.
Yes, 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 exactly.
Okay.
So 3 AND conditions they used. So first AND condition and second AND condition checks that whether there is existed path or not mutually, A to B, B to A, and third AND condition is there. This one, no, this one, these two. These are earlier they are not existed. Earlier A to B not existed, B to A not existed. Then only we'll update.
Yes.
Clear?
Yes, sir. Yes.
Yeah. So this is pretty much about the 9th week, but still the continued thing is there. So let me finish up this one. Now they want to do us 3 subject marks graphs. Mentor graph for maths is created. and mentor graph for physics is created here, and mentor graph for chemistry is created. 3 subjects. Now count that incoming. See, look at, the popularity they are trying to count it. So locally they are created one particular dictionary called popularity. This popularity, what it contains, so maths marks is there. For example, if you think about maths marks, already I said, so it is having sequence number 76, sequence number 92, sequence number 86. So this particular sequence number is used as popularity. So this is a kind of, math marks dictionary. Let you take a math mark. So another local dictionary is created, popularity. This popularity is initially a big dictionary. What it contains, popularity of I is 0. Popularity of the second student is 0. Popularity of third student is 0. Because initially, before you investigating about the student, what is his popularity? Just 0. He doesn't have any popularity. Now we check it. The maths marks adjacency, mentor graph you are checking. For example, this particular student is having relation. That's what, J is getting that relationship from the I. So then the popularity of this student is increased with +1. He is getting the help from some other student, +1. +1. What it is, this incoming edges they are calculating. This incoming edges. Maybe first student is getting the help from second student and third student also. Then what happens, this in degree is increased to +1 because he is having 76 of maths marks and he is getting the help from the second student, and of course he is getting the help from the third student also. So this popularity is being made it for each subject. First one, it is getting the popularity of that maths mark. Second popularity is calculated and incremented based on physics. Third popularity is getting the help from that chemistry marks. Maybe he is getting that from the second student, the help is maths, and he is getting the help from the third student is physics. Maybe he is getting the help from the fourth student, which is that chemistry. So what happens, in degrees incremented. So this is called in degrees incremented. So when the in degree is incremented, it indicates that he is popular in terms of getting the help from somebody. So this is what they want to tell you, that is called, incoming edges of the student. I hope you got it.
Sir, I have
Clear?
a doubt here.
Yes, sir.
Tell me.
Sir, I didn't get it. Like, who is helping to whom?
Yes,
Like,
see, very simple, very simple.
from J to I.
See,
Can you explain?
J to I. Because I is a particular key we are extracted. So we don't want to use I to J. We want to get it J to I. So what exactly, this is a mentor graph matrix. Is it clear? So here the mentor graph is there. Let it be that 3 students. Already 3 students. For example, whether 0 is popular or not, I want to check it. Clear? 0 is popular or not, I want to check it.
Yes, sir.
So then 0, if he is a popular, so 0 doesn't help to others, definitely. Clear? But 0th student, he gets the help from others. Like 0th student get the help from, so first student and second student. Clear?
Okay, sir. So
Of
here
course,
J.
yes. J is referring that row. This is referring row. I is referring column. Reverse they are doing.
So J
Fine.
is helping to I.
Yes, J is helping to I. That's the reason. See, look at J is helping to I. J is helping to I. J is helping to I. Of course,
Okay.
it is one particular maths mentor graph. It is maths mentor, physics mentor is there, and chemistry mentor graph is there. So these
And
3 in degrees are calculated. Of course, updated in single popularity graph only. but 3 in
Sir,
degrees has to be calculated, no?
sir, here we are calculating the in degrees of the variable I, no?
No, variable I you are incrementing, but in
Yes.
degree help from where you are getting.
So from J,
Yes,
we
yes,
are getting.
from J,
Okay.
from J only.
Okay.
If there
Okay.
is a path, we increment I.
Okay, sir.
Clear? That's simple.
So earlier we did for out degrees one, no? Like
Yes, yes, yes,
popularity.
yes, yes.
So this is
So,
the second way.
yeah, that's what the thing. Actually, popularity most of the times we check it in out degree and as well as in degree as per the lecture. Some students they help to other student and they can consider. Some student they get the incoming edges. In this case, we use J first and I next. That's it. Simple. Clear?
Yes, sir.
Yeah, this is pretty much that for the today, and same thing will be continued in the next, maybe before going for the 10th week. Please kindly refer it. I try to post this one, these particular summaries in the dashboard. So based on it, it could help it for 10th week and 11th week. Of course 12th week is completely revision only. That's the reason 12th week is complete. We spend much time on the this revision only. Okay, so hope you understand everything. Yeah,
Yes, sir.
yeah,
Yes, sir.
thank you.
So,
Yeah,
sir,
Excuse me,
Just
sir.
that
tell me, tell me.
PDF, can you share, sir, the PDF thing?
Yes, yes, that's what the thing. Immediately after the session, I'll ping this particular PDFs to support team. They try to add it into dashboard
Okay.
immediately.
Okay, sir.
Okay.
Excuse me, sir. I have only one doubt in the last pseudocode what you have
Yeah, yeah,
explained.
yeah, yeah.
That is, we are mentioning that matrix J of I, right?
Mm-hmm.
We could mention like that row as a J and I as a column also, or
Yes.
generally we will mention I as a row and J as a column
So if
only.
I as a row and J as a column, we go for popularity in terms of outgoing degree.
Yeah, that what I'm asking is here we are mentioning the J as a column or a row.
Yes. Now
I
J is
couldn't
used
get
as
that.
a row.
J is a row.
Yes. I is a
For
column.
our convenience, we can use in any way.
Yes, yes, yes. Because already in the matrices they said, default matrices is that row. Even you can refer that columns also, not issue. Columns can be referred as rows.
Sir, for example, I have a doubt that instead of writing like this, better you can write the match mentor I of j is equal to 0, and then popularity of j is 1.
That
Like
is
that also.
that is called this I of j, chemistry mentor of I of j equal to 1. Clear? Then what do you want to update it? Popularity of I
I,
plus 1. No, you want to do it? Is it
yes,
right?
yes.
Then out degree is calculated. It's not in degree because I is taken as row, j is taken as a column. From the I, either path is there. Here j is not used. This way is not used. This way is used. Is it right?
Yeah, then if you
Then
call it
out
for a
degree.
0, then it will be in a reverse degree, right?
No, 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 no. 0 is no path existed. Degree is there means definitely non-zero value. 0 cannot be considered as a degree. 0 means no path is existed. Only path is whether A is helping B or B is helping A. That's the thing. So that
Okay.
if you consider this is A, you are helping B.
We
If
could
you
not say
consider,
whether that I of j is 1. We could not say that j of I is equal to 0.
yes,
Like
yes,
that,
we cannot say, we cannot say.
we cannot say.
Yes, yes,
So we are considering
yes,
only from this side.
yes, yes. So
Okay.
this way A means this way B. If this way B means this way A. Simple. This way A means this way is B. If this way B means this way A. That's it. Simple. Here, out degree, in degree.
Okay, sir.
Okay.
So in the matrix, the first one which is written, that is that it is always helping or mentoring the other one, no?
Yes, yes, yes. Mentoring.
Like here J to I, so J will mentor I, or
Mm.
I is written first, so I will mentor J.
Yes, yes, yes.
So we
Okay.
have to consider out degree always.
Out degree only. If I is used, it means out degree. J is used, it means it is a in degree. Because outer loop is I, inner loop is J. Clear?
Yes, sir.
Yeah.
And
So,
sir, I have one more doubt, sir.
tell me.
So in that week 9 that you have explained now, no, week 7, that
Hmm.
pronoun one thing.
Hmm. Hmm.
So I have a doubt here. Can you explain it again if
Yes,
possible,
yes. Tell
sir?
me, tell me, tell me.
So this only that, yeah, for
Hmm.
this pseudocode.
Hmm. So in this pseudocode, what they did is, whenever matched noun is there, noun means definitely it has to be uh, early entry with a sequence number, like the word number. So they want to consider the word number or card number. 7 is a noun sequences. 9, 13. These are all nouns. Pronouns is there. So pronouns is something like bigger value than noun. Sometimes it is lower value also. 3, 8, 11, 13. So not 13 because already 13 is there. We want to make it 18, something like this. 18. Now what exactly mean that whatever pronoun is there, it will refer the previous value of that noun, which is a smaller value. Like 3, comparatively 3, any lower value is there? No. So that this 3 is not referring anybody now. For example, any noun, you find lesser value than pronoun. Yes, you find this match. Did you find this match?
Yes, sir.
Now what happens, this matched is updated. Matched is updated with a match D. It's a dictionary, which it contains the pronoun that is called, the pronoun 8. It is updated with matched of 7. So what happens, the dictionary, it is updated with 8 key with a value of 7. Fine. Clear?
Yes, yes, sir.
For example, what happens, another kind of noun is there, 6 also. So what happens, first 6 is updated, then 7 is updated. We don't have two values. Clear? Is it right?
Uh, y- yes, sir. So for 11, then how it will work?
Yes. 11 what happens? Yeah, so 11 is doing. So 11 what it will do, these two are matched. So once these two are matched, exit loop is done, matched is updated. Once it is like, forget about 6. We don't want 6 now because I don't want to make it you confuse in the 6. Yeah. Now that what happens, 8 is updated with 7. Once 8 is updated with 7, it goes to the next part of speech of pronoun, and it goes to the next part of speech of that noun also. See, both of them are going. So once both of them are going, now another uh, dictionary element is updated. So what is another dictionary element is pronoun sequence. The pronoun sequence is, yes, 11. It is having prefix in noun is 9. Fine. Clear?
Okay, so 8 is smashed to 7 now. 11 will not go towards 7.
Yes, no, it doesn't go because always it is skipping. No, that's what the thing. Once noun
Yes,
is over, then it goes to next noun only.
yes,
Clear?
sir.
Yeah.
Yes, sir.
So, but only
So,
issue is if
mm,
no particular pair earlier you find it, then what happens on latest pair only there. Earlier
yes,
pair
sir.
will go off.
So
That's
in
the reason.
case of the that you have taken for the 6, 1, 6
Hmm.
and 7, 8 will first update to 6, but then it found it is
Yes,
7, so it is
yes,
more closer. So
yes,
that's why.
yes. If more closer, the 7 is updated. So that's the reason to avoid that one, they go for that list with combination of dictionaries. Same match they referred in the 8th lecture is same thing, no? Here it is earlier one. Here it is. So I think, yeah, it is. I think here it's not used it. Even here also actually they want to update it. The updated dictionary of matched one, they did not talk about it. Of course, if they used it, they can maintain 6 and 7 also. They can maintain 6 and 7. Okay, clear?
Okay, sir.
Yeah, yeah, that's
Thank
it.
you, sir.
Yeah, thank you. Bye. Good night. Good night, everybody. I'll stop the recording.
Thank you, sir.
Thank you,
Okay.
Thank you,
sir.
sir.
Good night, sir.
I'll send the summaries. Okay.
Thank you, sir.
Thank you,
Yes.
sir. Good
Okay,
night.
sir.
Right. Good night.